Today's guest is Dr. Matthew Walker, author of New York Times bestselling book Why We Sleep: Unlocking the Power of Sleep and Dreams, professor of neuroscience and psychology at the University of California, Berkeley, and director of the Center for Human Sleep Science. You will note, this episode starts sort of abruptly. The opening discussion is about how sleep patterns change during human development, especially around age 12 months when motor skill learning increases. Matt and I had planned on doing an intro, but the camera was rolling and the discussion was so interesting that we just kept going. This one is a good one, folks. Enjoy.
What's really interesting is that if you look at sort of sleep, and we've done some of this work, and maybe we'll speak about it, on sleep and motor skill learning, and that seems to be more dependent on this sort of lighter form of non-REM sleep, stage 2, and particularly the burst of electrical activity, the sleep spindles. There's a really bizarre bump in stage 2 and sleep spindles during development. It happens right around the 12-month period, which is where all of a sudden you start to see considerable limb or multi-limb coordination. In other words, you start to perambulate, you start to learn how to walk. It's almost as though there's like a homeostatic response, which is that with the drive for motor plasticity and learning comes a response from sleep to say, oh, now we're into motor skill learning, we need to consolidate. And you get this, it's a really strange bump, and it dies away again after.
What's the sleep to spindle? What is it? What stage is that?
You see sleep spindles throughout almost all of non-REM. So once you get past the lightest sort of stage 1 non-REM, then you get spindles throughout all of non-REM. But they are a prototypical feature of stage 2 non-REM as well. But then stage 3 and 4, which is sort of like the deep sleep stuff, you also get spindles there too. But in our hands, at least, the strongest sleep stage and the strongest electrical signature in your EEG that is predictive of your motor skill learning is stage 2 and sleep spindles, both of which seem to have this bizarre sort of, coincidental spike right around this developmental phase of crawling, standing, walking.
So many things going on during the development. It's so fascinating to observe, for sure.
And language too. When we've looked at this as well with teaching adults foreign languages, or even actually just mathematical languages or artificial grammar, sleep is a huge component in that. But they also saw this fascinating thing with development, which was about not just concrete learning of individual facts, but the generalization of knowledge. So this is sort of the thing that I think separates us from computers, at least for now, which is that computers are very good at storing individual bytes of information in a veridical way, very clearly. And we can do that too, storing individual facts. But what computers don't do, which is what we do, is intelligently integrate and associate them together so that we can extract overarching patterns and schemas and statistical rules about this thing called the world in which we live. And I was just going to say that you can, with infants, you can teach them just these novel sounds, and each one of these strings of sounds is unique and different. But there's something common about the grammar that is binding and overarching across all of them. There is an overarching schema that you could learn in addition to each one of the individual facts. After they've had a nap versus an infant that has not had a nap, post-nap, the infants have extracted and understood the generalized rules of what they've been learning, not just the individual facts. Whereas infants that have learned but haven't napped have not sort of made the abstraction.
So being a nap Nazi, I should be rewarded for that, right?
Absolutely. And it stays from infancy all the way through to adulthood. So if you're napping, there's a few double-edged sword aspects of napping.
So I wanted to ask you a question. You're talking about basically being able to connect the dots, so it's how that sort of differentiates us from what a computer can do. One of the things. But is there a certain, I remember reading in your book, and this is probably the part of the book that I was more skimming, and that was the importance of REM sleep and dreaming and creativity.
Yeah.
So is that connecting because I feel like connecting the dots is some it requires some creative thought to be able to kind of like put things together and come up with the big picture idea and figure things out. So is it known? Is REM sleep important for that?
Yeah, it does seem to be. So if there is So, I mean, we could take a step back and think about how does sleep achieve memory processing, learning, information processing? And sleep seems to be important in at least 3 ways. First, you need sleep before learning to actually get your brain ready to initially soak up new information, to initially lay down new memory traces. But you also then need sleep after learning to take those freshly minted memories in the brain, particularly in a region that we call the hippocampus, which you could think of almost like the informational inbox of your brain, that it's very good at receiving those sort of new memory files. But you need sleep after learning to take those new memories and then essentially hit the save button on them so that you don't forget those informational pieces of the puzzle. So sleep before learning to get your brain ready to acquire information, sleep after learning to hold on to those individual facts.
So let me get this straight. So if you want, for example, short-term memory, right? Because if you're sort of wanting to store things in the hippocampus, even short-term, that would be sleep before.
That's right.
And then if you want to then consolidate it and have a long-term memory, that would be your sleep after?
That's sleep after.
Okay.
So you can't cheat sleep on either side of the memory equation. You can't pull the all-nighter and hope to be able to continue to learn. And we did this study. We said sort of, is it wise to pull the all-nighter before the exam? So we took a group of individuals, assigned them to one of 2 groups, a sleep group and a sleep deprivation group. Sleep group, they get a full 8 hours of shut-eye that we measure here at the sleep center. The deprivation group, we keep awake all night under full supervision, and they don't get any naps. There's no caffeine. It's miserable for everyone involved, and no caffeine at all. And then the next day, we placed them inside an MRI scanner, and we had them try and learn and cram, essentially, a whole list of new facts into the brain, into the hippocampus. And the first result was that the sleep deprivation group was about 40% more deficient in their learning ability. So they learned 40% less, 40. Which is
astronomical. That's a huge...
non-trivial. I mean, if you want to put that in context, I guess it's the difference between acing an exam and failing it miserably, 40%. Totally. What was interesting, though, was what was going on in the hippocampus, this informational inbox of the brain. When we looked at that in those people who'd had a full night of sleep, you saw lots of healthy learning-related activity. It was beautiful. In the sleep deprivation group, we actually couldn't find any significant signal whatsoever. And so it was almost as though sleep deprivation had sort of shut down your memory inbox, and any new incoming files were being bounced. And we put forward a theory as to why that was. Perhaps that the hippocampus, being a short-term reservoir of memory, has a limited storage capacity.
Yeah.
Perhaps a little bit like a USB stick. And you have maybe in humans a 16-hour recording capacity for information acquisition before you have to sleep. Because it's during sleep then after learning. So that's sort of the story before learning. It's not great. We can show it. We know in the brain what part of the brain is failing to produce those impairments.
In that study, you were testing the ability to acquire new information.
Exactly, to sort of lay down those fresh memories and just to grab hold of them. And you can't do that well without sufficient sleep. And that seems to be in part related to your non-rapid eye movement sleep or your non-REM sleep. But then what we've also done in lots of studies, and we and lots of other people have now replicated this finding, sleep after learning then takes those memories and I said sort of hits the save button on them. It's a little bit crass. Actually, what really happens is that during sleep, there is a file transfer mechanism that takes place at night, that we shift memories from that short-term vulnerable storage reservoir, the hippocampus, and we move them out to the long-term storage site within the brain, which is the cortex, which essentially acts like a hard drive. And that means that when you wake up the next day, there are 2 delightful benefits. First, having shifted those memories from the short-term vulnerable reservoir to that more permanent sort of safe storage haven in the brain, they're protected and they're safe so that you're going to remember rather than forget. The second benefit, however, is that sort of having cleared off those files from the hippocampus, almost like shifting files from the USB stick, you've cleared out all of that fresh memory encoding reservoir so that when you wake up the next morning, you can start acquiring new files all over again. So it's this sort of elegant symbiotic system of memory that happens.
Yeah, beautiful.
Yeah, absolutely. Sorry.
Well, we'll, of course, use all this.
It's hermetically sealed. It's bizarre.
I remember reading somewhere that when you sleep, and this is related to what you were just talking about, that your brain sort of replays, like electrical activity-wise, it looks like you're literally like reliving the same thing you just learned or something. Is
That's
that
absolutely correct. So these studies firstly happened in animals, and we've now been replicating some of them with brain imaging, with MRI scans in humans. Hard to believe, but we can do it. But the original findings were fascinating. They would place electrodes into that structure that we spoke about, the hippocampus, which also rats have as well. And it helps rats learn spatial navigation. And they would place lots of electrodes into this part of the brain. And as the rat would run around the maze and learn the maze, individual cells would fire and they would spatially code which part of the maze the rat was in. So different cells are mapping different parts. It's like sort of navigating a route from your home to work. Different sort of cells are coding the journey along the way.
Yeah, I probably would suck at doing that, but...
And I lost that. Some people say it's a male aspect of the gene, but I definitely lost it anyway. But what was delightful was that you could sort of hang, a sound tone on each one of these electrodes. And what you would hear, and this is just, for audio, you would hear sort of ba-ba-ba-bum, 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 as the rat was running around the maze, as these cells were learning and coding and creating this kind of memory circuit, essentially. And it's ba-ba-ba-bum, off it goes. But what was genius is that they kept recording, and as the rat fell asleep, what did they hear? And it wasn't just static random firing, which is what we thought typically happens during sleep. In that static of electrical impulses at night, in this sea of electrical noise, came out a very clear predictive message, which was brum, brum, brum. So it was exactly the same temporal sequence, bum, 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 but it was sped up. And we now know that it's during sleep that we replay, but we replay at somewhere between 10 to 20 times the speed. So it's as though you're kind of, you've done the, recording of whatever happened during the day, but then it gets replayed, but at times 20 or times 10.
Wow. So is this the long-term potentiation part? Is this where it's solidifying? Now, what stage of sleep is that?
So that's during deep non-REM sleep.
Deep.
Yep, that we see.
So it's the sleep I'm always trying to optimize for, and it's just so difficult.
And it's difficult, I think, sleep in general is difficult for so many people, and we can speak why, but so this starts to come back to your original question about REM sleep, though. So we get this memory replay, absolutely fascinating. We can now see it in humans. We can even manipulate it, which is amazing. So if I teach you some information on a screen, let's say it's about a particular object, like a fire engine, and you have to try and learn both the object and the spatial location of that on a screen. Mm-hmm. And then tomorrow, we're going to sort of come back, and I'm just going to show you the image and say, do you remember seeing it or not? Yes or no? And if you do remember seeing it, you've got to place where you thought it was on the screen. So you have to learn the item, and you have to learn the associated location. But here's the great part. During the initial learning session before you slept, not only do you see the fire engine, but we play the sound of the fire engine, like a fire engine ring. And then we show you a kettle, and it's whistling. Or we show you a cat, and it's meowing. So each of these items that you're making has a contextual cue associated with it, a sound. And it's a congruent sound. Fire engine sound, fire engine, kettle sound. And here's the fun part. I can teach you 100 of these items. And then during sleep, I'm going to replay those sounds that you heard as if I'm trying to get into your brain, and I'm selectively reactivating each one of those individual memories. But I'm only going to reactivate and replay half of those memories. I'm only going to replay 50 of the 100 things that you've learned. And then the next day, we wake you up and we test you. And firstly, your memory is better after sleep, and that's what we found. what's interesting is that for those items that I replayed during sleep, they are almost twice as superior in terms of your memory retention.
So the playing of them doesn't disrupt the sleep at all, or?
Well, that's the key. You have to play at a sub-threshold awakening sound. So we will test your auditory threshold, and we will then play the sound at a level that we know is below your awakening threshold. So it's still just enough to get in, to penetrate into the brain and tickle the memory and reactivate it.
That's fascinating.
But it's not enough to wake you up. So now, you could imagine, I've got these science fiction ideas of thinking, well, I learn all of this information, and maybe I can just put my favorite playlist on, at night at low sound and, stimulate these memories. Or could it be a study aid where you help students learn sci-fi stuff?
So you think coupling different sounds maybe with, learning facts, it may actually help?
Yeah.
Like, irrespective of replaying them like during sleep, do you think just even the coupling of the sounds somehow can help?
As long as those sounds have been coupled and bound to specific information, and this is what we call context-dependent or cue-dependent memory. This is well known in psychology over about 100 years. If you study in the room that you're going to take the exam, you do better because you actually use cues, contextual cues from around the room that are triggers to help you better remember.
Wow. So
we're just doing that with sleep.
What about caffeine? So if you study caffeinated and you don't take your exam caffeinated, is it this kind of the same concept?
We don't know about caffeine. That's an interesting thing. Caffeine may be it's a non-specific stimulant. Whether it works with ingested substances, we know, however, this works also with odors. So have you ever had that experience where you're sort of in an airport and you're sort of tying your shoelaces after security, someone walks past with that cologne or a perfume of a person you knew, and it instantly unlocks that memory, as if the sound has triggered the reactivation of the memory and it comes flooding back. Well, you can do the same thing with this memory and sleep trick, where I teach you stuff during the day and we can puff certain odors up your nose and associate the smell with the learning material. And then during sleep, you reperfuse the odor up the nose.
Oh, really?
And you can get the same benefit as well, the same doubling of memory benefit.
That's fascinating. I remember the study that was done that was coupling an odor. It was like a cherry blossom odor with electrical shocks. So there was classical fear studies that they do in mice. This was in rodents, and there was some sort of epigenetic change that the breathing of the odor or the cherry blossom was inducing. That was like changing some receptor on the glucocorticoid receptor. So it was getting passed on to like the next generation. And so even though the next generation didn't have the shock and the coupling of the smell, if they were exposed to the smell, they had a fear.
The memory was translated from one generation to the next.
Anyways, it'd be fascinating to know what role sleep plays in the epigenetic transfer.
Right. So if we all start doing this, are our children going to be incredible memory replayers? By the way, but to come back to I'm sorry, I've taken a desperately long time to answer your original question, which was, what about REM sleep? So what we've spoken about is the first two of the three stages of memory processing with sleep. Sleep before to get the brain ready to lay down memories, sleep after to grab a hold of those individual memories and cement them into the neural architecture of the brain. Once you've done that, though, there's a final step, and that seems to not depend on deep non-REM sleep, but instead depend on rapid eye movement sleep, or REM sleep, which is what most of us know as dream sleep. And it's during dream sleep that your brain essentially performs informational alchemy, is what I would describe it as. It's a little bit like group therapy for memories, that sleep has gathered in all of the information during the day. And during non-REM sleep, which always comes first, by the way, in our sleep cycle, we always have non-REM sleep first, then REM sleep second, then non-REM sleep again, then REM sleep second. And we don't know why. There is no good explanatory data suggesting why non-REM sleep always comes first and REM sleep comes second. But I've put forward the theory that for information processing, it makes sense, which is that non-REM sleep first to just get what you've learned and lock it into the brain. REM sleep then comes along, and REM sleep starts to fuse all of the information that you've recently learned with the entire back catalog of information that you've got stored up across a lifetime of experience. And it's this sort of, essentially REM sleep is creating a revised mind-wide web of associations. And I'd like to sort of think of what's going on with REM sleep. And we've done lots of these studies to look at this. And there's clever ways that you can look at sleep and associative memory processing and building new novel connections. And it's almost like memory pinball, where you take these new memories and you sort of launch them up and you start bouncing them around into the architecture of information within the brain. And you're starting to test associations. You're starting to say, should this new information be connected to this? Maybe not. Should it be connected to this? Maybe not. Now, some of that happens whilst we're awake during the day. We make obvious connections. But what's strange is that we make connections during REM sleep, but they're not of the same kind. The connections that we're making during REM sleep are the long shot. This is the bizarre,
right.
Strange, it would be the equivalent of saying during the day, we take this information and the connections we make are like a Google search gone right, which is the first page is all of the things that are most related. And it's very obvious, page 1, that's directly related to what I inputted. During REM sleep, it's almost as though you input the search term and you're immediately taken to page 20 of the Google search, which is about some field hockey game in Utah. Yeah. And you think, hang on, I don't understand. Oh, that's interesting. I see what you're talking about. So we make these bizarre leaps of associative memory processing faith during REM sleep. And that's why we now understand that it's REM sleep that helps us divine remarkable creative insights into previously impenetrable problems. And you can see this throughout the history of human beings, this dream-inspired insight. Scientific demonstrations, August Kekulé divined the idea of a benzene ring, these double carbon rings, by dreaming of a serpent that swallowed its tail. Dmitry Mendeleev, came up with the periodic table of elements by way of dream inspiration. People have won Nobel Prizes. Otto Lowy won the Nobel Prize for the demonstration of chemical transmission across nerve cells. And he dreamt of the experiment that helped improve that. He didn't dream of the concept itself, but he dreamt of the experiment to prove it. Wonderful artistic demonstrations of this too. Paul McCartney has written innumerable songs, it turns out, by way of his dreams. Keith Richards came up with the opening chords of Satisfaction by way of dream-inspired insight. So REM sleep takes that third component of information processing, and I think it's what defines us differentially from computers in part, which is that deep sleep is about knowledge, which is gathering all of the information and holding on to it. REM sleep, I would argue, is about wisdom, which is knowing what it all means when you fit it together. That's what I want from a good student. Don't just give me dry book learning. Do you really understand it? Can you apply it? Are you creative? That's dream sleep.
Right, a deep thinker. Why do you sometimes not remember your dreams and sometimes you do remember your dreams? Do you have any idea?
Yeah, so some of it seems to be about if you wake up out of that dream sleep period and then you go back into sleep, the awakening can sometimes help you commit that experience to memory. Oh, okay. But there are people who say that I never remember my dreams. We can bring those people into my sleep center and we can, wake them up in the middle of dream sleep and they'll say it's remarkable for the first time I was dreaming. And the answer is no, it's not the first time that you were dreaming. It's just the first time that you've actually remembered a dream because it's the first time you've typically woken up.
Okay. My mother-in-law, claims that she doesn't dream. And of course I'm like, no, you have to dream.
Yeah, there are a selection of patients that have a lesion in a part of the prefrontal cortex in their white matter, which are these big sort of informational fiber tracts that communicate impulses. If you get a lesion deep down there, we do seem to genuinely see a cessation of dreaming in those patients. By the way, I didn't even feel confident to write this in the book, and it's still a theory that I've never really aired in public, but go with me on this, which is I think that we may actually remember all of our dreams, or it's possible that there's a tenable theory. The problem is we don't have access to those dreams. Those dreams are memorized and they are available, they're just not accessible. I think what happens as we wake up is that we lose the IP address to those memories. And the reason I believe this to be potentially true is, have you ever had the experience where you wake up and you think, I was dreaming, and I know I was dreaming, and you try as hard as you can, the harder you try, the worse the memory recall goes, and then you think, oh, forget it. 2 days later, you're walking along and you see a street sign, and all of a sudden it triggers the unlocking of that dream memory. You think, oh, that's what the dream was about. As a neuroscientist, that tells me that the memory was present, the memory was available. The problem was accessibility. You couldn't gain recall access. So the information is there, it's just not accessible.
Yeah. It's happened to me just even after I've, when I go to bed, then, later that night, I hit the pillow and all of a sudden I remember the dream right as I'm hitting the pillow.
Right.
That's happened to me more than once.
Which sort of tells you that there is, it's almost a scary prospect, which is that maybe every single one of our dreams throughout life are stored and are present and determine our behavior to some degree. Because we know that there is an enormous amount of information that changes our behavior and our decisions, that goes on below the radar of consciousness, implicit memory. That could be true for dreaming too. And I think I've got an experiment that we may be able to design to actually get at this. And if that's true, it should hopefully radically change our view of dreaming, that dreams are ephemeral, that they dissolve quickly, they're forgotten, and they don't influence us as a human species.
That would be pretty groundbreaking.
Yeah, we'll see.
You just had a study I just read, I think yesterday on sleep and it affecting behavior, loneliness.
So we just published a study demonstrating that sleep loss will trigger viral loneliness. And it was a 3-part study. Firstly, the reason that I got into this was loneliness is a killer. We know that there is a massive epidemic of loneliness now in industrialized nations. Being lonely increases your mortality risk by about 45%. In other words, being lonely is twice as risky for your death concern than obesity.
Wow.
Which is striking.
Yeah, there was actually a study showing loneliness changes like a massive amount of gene expression and like upregulates NF-kappa B, cortisol, like all these pro-inflammatory genes. So it makes sense that they'd be associated with.
And what's bizarre about loneliness, by the way, I'm taking this has got nothing to do with sleep, but if you look at the profile of your gene expression and your immune system, you've got some immune components that will go after viruses, and viruses can only be transmitted from one human being to another by way of touch. They can't live outside of our bodies. Bacteria, so if you scrape yourself on a fence, like, walking past it, you can get a bacterial infection because bacteria can live outside of the body. When you become lonely, your gene expression shifts you away from a profile of immunity that normally deals with viruses and pushes you more towards a bacterial defense profile.
Really?
Isn't that incredible? That
you
your
have to send me that study. That's fascinating.
And there's a couple of folks at UCLA who, if you ever have interest in this area of how loneliness, the mind, mood.
Oh, totally.
Okay, I've got to give you these people. I'm a complete fan of their work, and they did this study, and it just blew my mind. How could a concept that is so sort of out there, and some people almost don't believe in loneliness, toughen up, what's wrong with you, go out and make some. How could that change the expression of your genes and even alter how you, the organism, fend for yourself from an immunological perspective, shifting you from viral to bacterial defense? But anyway, so coming back, I was desperately concerned about this state of loneliness. What was interesting, I was reading a lot at the time, because we do a lot of work with sleep and psychiatric disorders, including anxiety. And when I was reading the studies where they would take animals and they would deprive them of sleep, you've got this anxiogenic profile where you've got cortisol increasing, you've got a shift in insulin, glucose regulation, all of the bad things that you would not wish to happen, and anxiety increase. They had fear-like behavior, all by way of just sleep restriction. But what was also interesting is that sometimes the researchers would note, despite not measuring it systematically, that the animals would often be secluded by themselves in the cage, even when they were with other conspecifics. And other conspecifics would not approach them either.
Okay.
And so it seemed to me, just from reading this, I thought, well, this seems like an animal phenotype of human loneliness. And it seems to be caused by a lack of sleep. So we decided we had to do the study. And so the first part of the study, we took a group of individuals and they went through the study twice. They were either deprived of sleep for an entire night or they got a full 8 hours of sleep. The first test was, do you have a social repulsion boundary? And that boundary is increased when you are sleep deprived. So I think everyone has that sense that if I start moving closer to you, you think, okay, do you know what? At some point, that's kind of enough. That's about my close distance. What's interesting is that if I ask a sleep-deprived individual to stay put, and I ask you as an experimenter to walk towards the sleep-deprived individual, and the individual says, stop when they feel comfortable, relative to when that very same individual has had a full 8-hour night of sleep, when you're sleep-deprived, you decide to push people a further distance away from you. So you have a lowered desire for social proximity and social interaction. Second, we then replicated that finding, but now we had them inside the MRI scanner because we wanted to see what was changing in the brain to produce this social repulsion. What we found was that the regions of the brain that are essentially an alarm network, which is a sort of a stay away from me network that is sort of in the parietal cortex and the premotor cortex, it's sort of what we call the near space network. So it creates your comfort of boundary, and when objects start to approach you, it alarms to say, incoming, be cautious, be wary. That part of the brain became hyperactive when people were sleep deprived.
Wow.
As if you were getting this repulsion signal from the brain. If that wasn't bad enough, the other parts of the brain that have been called the theory of mind network, which sort of helps you understand the intent of other people. It's a pro-social network in the brain. It cooperates pro-social interaction. That part of the brain was shut down by sleep deprivation.
Wow.
So it's a double-edged sort of sword.
Yeah.
So we weren't satisfied with that. Next, we wanted to say, could someone who just looked at these sleep-deprived individuals, could they actually judge them as being lonelier and looking lonelier and being sort of perceived as lonely, even though they knew nothing about the experiment? So in the experiment with the sleep-deprived individuals, we also did videotaped interviews with them. And we just asked them general questions. Tell us about a movie that you watched or what was happening in the news this week, just bland stuff. And then we got 1,000, I think it was over 1,000 people, 1,083 people online. And they knew nothing about the experiment. They didn't know it was about sleep deprivation, knew nothing. And we showed them just a 60-second clip of these people when they'd had a good night of sleep and when they were sleep deprived. And we just asked them, how lonely does this person appear to you? And they knew nothing, but despite knowing nothing, they consistently and reliably rated the sleep-deprived version of the individual as seeming lonelier. We also asked them, would you socially interact with this person? Would you friend them on Facebook? Would you work with them in a business environment? And they consistently rated that they would prefer not to engage and interact with them.
Is that because they just looked unhappy or looked?
Well, we actually think it's a collection of things. It's that their appearance, but also their vocal tone is very different. And we think there's a lot of this is now one of the key things. What's communicating this asocial profile?
Oh, so they were listening to them speak.
So they watched them and they listened to them speak, so they could hear them as well. So we demonstrated that there was, unfortunately, this social repulsion on both sides of the equation. When you're sleep deprived, you yourself don't want to have anything to do with other people. And that perhaps wouldn't be so bad if people would only at least come to your rescue because they would see you in need. The opposite is true. People find you socially repulsive as a consequence. So there's a push from both sides of the social dyad. The next thing we asked those people who were rating the sleep-deprived individuals, we also said, look, how lonely do you feel after just this 60-second clip? And they themselves felt lonelier after interacting with sleep-deprived individuals. In other words, there's contagion of sleep deprivation-induced loneliness.
So I wonder how much of this can be translated to like someone that, say, for example, gets only 5 or 6 hours of sleep versus, of course, not getting a full night's sleep. You know, maybe there's like just a little bit of this penetrating.
Well, we then asked that question. That was the final part of the study, which is that we said, okay, this is extreme sleep deprivation, and most of the population does not undergo this. What about a more ecological version? So we tracked hundreds of people across 2 nights of sleep. And we asked, is just by a subtle variation of nature, are small perturbations of sleep from one night to the next, do they predict how lonely you experience yourself to be from one day to the next? And these are small, minute changes in sleep efficiency, just small reductions in sleep of tens of minutes. Lo and behold, even just that small change in your sleep from one night to the next, we could measure, predicted how lonely you would experience life the next day from one day to the next. So it doesn't even take, 2 hours of sleep reduction.
Wow.
Small minutes.
I remember reading somewhere too that isn't the like amygdala like hyperactive or something happens. There's not like an inhibitory signal that occurs if you're sleep deprived. Or,
That's right.
Is that correct?
Yeah.
So then you're feeling more, you're like alarmed and just anxious and feeling that threat.
That's right.
That ongoing threat that really isn't there.
Exactly. Yeah. So we published this study in 2007 where we again, sort of sleep-deprived people, put them inside an MRI scanner, and we showed them increasingly negative and aversive and unpleasant images. And what we saw is that relative to people who'd got a full night of sleep, the amygdala, this sort of emotional epicenter for the generation of strong emotional impulsive reactions, that deep emotional center was 60% more reactive under conditions of a lack of sleep. And then we asked why. Why is your emotional brain so sort of sensitive and erupting with such extraordinary activity? And what we then went on to find out in later work was that another part of your brain called the prefrontal cortex that sits directly above your eyes here, and particularly the middle part right between your eyes, that part of the brain acts almost like the CEO of the brain for your emotions and your hedonic impulses. And it sends sort of an inhibitory top-down regulatory control. It's sort of like the brakes on the gas pedal of your emotions. That part of the brain was shut down by sleep deprivation, and you'd lost that communication to the amygdala. So now you, from an emotional standpoint, you were all emotional gas pedal and too little regulatory control brake, as it were.
It's really interesting. This work kind of reminds me of, I'm not sure if you're aware of any of this research. A lot of it's been done by Dr. Molly Crockett, who I believe now she's at Harvard. But she has done a lot of studies looking at serotonin depletion in the brain.
Yeah.
And basically you can induce that by giving acute tryptophan depletion, giving someone like branched chain amino acids to compete with transport for tryptophan in the brain, which then basically drops serotonin levels. I mean, you can drop your serotonin levels down to like 10%.
And mood, and
the same thing happens where exactly what you were describing, the inhibitory signal that happens from the prefrontal cortex onto the amygdala is like stops. And so people become extremely impulsive.
Yep.
They become in terrible moods, a little more aggressive. Their long-term planning shuts down, and they just like going for the short-term gratification.
Yeah.
Very similar. So it'd be kind of interesting. I don't know how serotonin would be related to all that, but there must be some sort of connection.
Yeah, I mean, and I think there's a number of different, neurochemicals that can produce that same kind of neural phenotype, as it were. But what struck me was that when I looked at that neural signature of sleep deprivation for the emotional brain, it was not dissimilar to numerous psychiatric conditions.
Right.
And that then now, 11 years ago, showing my age, but that set sort of, the Sleep Center off on a completely new trajectory of work, and we're doing a lot of this work in sleep and psychiatric disorders. And I think one of the most fundamental things that I can say at this point is that we have not been able to discover a single psychiatric condition in which sleep is normal. And so I think sleep has a profound story to tell in our understanding, maybe our treatment. I don't know about prevention, but possibly of grave mental illness. Mm-hmm. And psychiatry has known this, by the way, for 40 or 50 years. It's always been documented that sleep disturbance goes hand in hand with psychiatric disturbance.
Maybe there's some sort of complex gene-environment interaction. People that are more genetically susceptible and are getting losing the sleep are like the ones that are kind of pushed into a disease state.
And we've seen this too, that if you look at that emotional brain reaction signature that I just sort of described, and you repeat that, but with people who are high anxious and low anxious, and we know some of the genes that are associated with being high anxious and low anxious. So we're using anxiety as a sort of a proxy for perhaps a particular genotype here. What you see is that it's those high anxious people who are the most vulnerable to this impact of a lack of sleep. Those who are low anxious still have a bad outcome, but it's nowhere near as bad. So there seems to be sort of interactions here between sleep loss and your basic trait levels of being sort of a nervous, anxious type to begin with. And those are the people who are, sadly, the people who typically don't get a good night of sleep anyway.
Right. So I was going to say, anxiety is like one of the things that stops me from sleeping.
It's the principal trigger of insomnia. It's the model of insomnia
truly,
right now. Is that you get, and if you look at the nervous system, that's how we understand insomnia right now, is that it's principally, I think ultimately we'll find that there are multiple flavors of insomnia, different forms. We already categorized two of them. We've got what we call sleep onset insomnia and sleep maintenance insomnia. Difficulty falling asleep, difficulty staying asleep. They're not mutually exclusive. You can have both, or you can just have one or the other. But coming back to it, I think the overarching biological red thread narrative of insomnia is an amplified fight or flight nervous system. That your nervous system is split into these two branches, what we call sort of the sympathetic and parasympathetic parts of your autonomic nervous system. The sympathetic is anything but sympathetic. It's poorly named. It's the fight or flight branch of your nervous system. It ramps you up, charges you up, releases cortisol, adrenaline. You constantly see an overactive sympathetic nervous system in people with insomnia. And when you measure their cortisol across the 24-hour period, in most of us, just as we're getting to our natural bedtime, cortisol just starts to now drop down. We start to see that cycling down of cortisol. The opposite happens in people with insomnia. You get a continued rise right around that bedroom period, and it seems to be very predictive of sleep onset problems. If you look throughout the night, cortisol then starts to plummet and it drops beautifully down. It's part of the reason why deep sleep is the best form of natural blood pressure medication that you could ever wish for. Your heart rate drops down, your vessels relax, cortisol drops down. But in other insomnia patients, we see this bizarre spike in cortisol in the middle of the night, and it predicts nighttime awakenings. It predicts sleep maintenance insomnia.
I have experienced, that's one of the problems that I actually have. It's much, much better now that my stress level is like maintained.
Yeah.
But in graduate school, I would get nighttime awakenings where my heart would start racing and I would wake up thinking that there was a spider or some kind of threat, and I would scream and sometimes jump fly out of the bed. I mean, and just, it would scare my husband, at the time we weren't married, but I mean, these nighttime awakenings, it was something that's dated back for quite some time, but really it manifested during a very stressful period, and that was graduate school.
We see that
got much better
so frequently.
Yeah.
That if you can think about that as sort of a stress management component to insomnia, it's part of what we call cognitive behavioral therapy for insomnia, which is sort of dealing with that stress. Meditation. There's great apps out there like Headspace, for example. And the data on meditation and insomnia is very, very powerful. I'd known about it a little bit, but I hadn't read really all of the studies until I started researching it for the book. And I was so convinced that I started meditating, and I haven't stopped since, because it was, typically I'm not a bad sleeper. I'm a light sleeper, but I'm a pretty good sleeper. I found it hugely useful for times when I was under stress or when I was traveling and jet lag. It's very beneficial too. But that underlying theme, I think, is a message for insomnia. It's not the only cause of insomnia, but it seems to be, if there's one common sort of rule that binds many of the patients with insomnia together, it's this overactive fight or flight branch of the nervous system. And if you can settle that down, you are certainly on the path towards better sleep.
Right. And to kind of just another point that you made was talking about, the hormonal response and the cortisol rising typically when it's supposed to be falling, and that kind of prevents you from falling asleep. There is some interesting research that I've read where, and I know you and I have talked about the importance of bright light exposure. And bright light exposure for 6 hours a day, I mean, no one does that nowadays. We're always inside. So it's like, it's rare unless you're like working out in a nature park or something.
The irony of these things is not, it's for the camera, I promise.
Right, but it actually, it was shown to lower cortisol by 25%. So this is like, another kind of, I don't know if that would even help someone with the anxiety or,
no, I think
maybe
it's, there's no studies testing it yet, but there are studies. So just to go back to make this point, we normally have a circadian rhythm, this beautiful sort of 24-hour rhythm, and we human beings, we're diurnal and we like to sleep at night, be awake during the day. We have this awesome upswing of our circadian rhythm, sort of once we wake up, sort of 7, 8, 9, 10, 11. It starts to peak during the day. It drops down a little bit in the mid-afternoon, and that's why you sort of get around meeting tables in the middle of the afternoon, these sort of, head nods. It's not people listening to good music. It's like actually, there's a pre-programmed dip in your alertness, and then it rises back up, and then it drops down at night. And one of the ways that you can get this sort of what you would want, which is a nice sinusoidal wave, you want a nice strong peak of the circadian rhythm during the day so that you're awake and you're active during the day and you're productive. And then you want an awesome sort of trough throughout the night so that you sleep soundly, deeply, and in a stable fashion. And the way that you can sort of help your circadian rhythm have that wonderful peak and delightful trough is by getting lots of daylight during the day, but lots of darkness during the night. And we are a dark-deprived society in this modern era, and it is a huge problem in the evening. But I think people have underestimated that we are a light-deprived society during the day. So what happens is that your brain goes through life in this kind of almost stupor state where it's not getting enough daylight to really keep it ramped up throughout the day. So you're sleepy throughout the day and you're tired, but then we've got too much light in the evening, so you end up being awake at night. So and then you're sleepy during the day, you're awake at night. And so it's, it's almost like I would call it a seesaw. I think we call it a teeter-totter here. During the day, you want daylight to come in and force you all the way onto the on switch, and you're active and awake. And then at night, you want the signal of darkness to come in to trigger the release of a hormone called melatonin to shift you all the way into the off position, so you go into deep sleep and a sound sleep. But now with artificial light and staying out of bright light, sort of the teeter-totter is just pushed a little bit to one side, and then sort of with not enough darkness at night, it's only pushed a little bit down on the other side. So you kind of have this flip-flop switch that it's like a dimmer switch that is basically just on dim for 24 hours rather than light and complete darkness, if that makes sense.
Yes.
It's a terrible analogy. But
do you have any idea like how much bright light exposure, like, let's say, a lot of people work in like a little cubicle where they don't even have windows. I mean, they're just like in the middle of this like little room with no actual sunlight coming in. Is something like if you wake up in the morning and you go outside for 30 minutes or an hour first thing in the morning, like most people are drinking their coffee. Well, maybe what you need is bright light exposure instead of your coffee, or drink your coffee outside, whatever.
Right, yeah, take the coffee on
do you know how much light you need? And if you don't have light outside, let's say you live in London and you're in the winter and there's it's just gray.
Well, even on a cloudy day, the lux intensity of light far exceeds that you would have from incandescent light or at sort of typical lights inside of a building.
Okay, so that would be my second question, the lux amount. So do you know?
Yeah, so I think, if you look at the studies, once you get over a sort of, about sort of 5,000 to 10,000 lux, you can have a pretty powerful effect. Okay. I don't believe there's, and I could be wrong, but and Sachin Panda, our good friend, who is just A+. In fact, if you're watching this, stop watching this now. Just go and watch the Sachin Panda podcast. He's much more powerful and eloquent than I am. But they have looked at the degree of exposure to outside light, not necessarily the intensity of light during that outside exposure time. So I don't think we yet understand exactly what the dose response is in terms of lux intensity. What we do know is that getting 30 to 40 minutes of outside morning light is critical. But here's the trick. Here in California, a lot of people make this mistake, but even in London, it happens despite cloudy day. People put shades on in the morning. Don't do that. I know it looks good, And but don't you let that natural light penetrate your eye.
Right.
There's a retinal mechanism that goes through to your thalamus, that then goes through to the hypothalamus that regulates your circadian clock, and you need that light penetration. You're losing all of that good stuff, or some of it, if you put shades on. Wear sun protection, that's fine. Just nix the shades in the morning. In the afternoon, reverse the trick. And this is actually a very good tip for jet lag. Jet lag is essentially an extreme form of what most of us have, which is this, what we've been describing, this diluted amount of light during the day and then too much light at night. Jet lag, you really should get out in the morning, 40 minutes of daylight, no shades. And in the afternoon, it's fine to go out. But when you go out, now's the time to put shades on, because you can start to encourage even then the release of melatonin, which is that hormone of darkness, which signals the timing of healthy sleep.
So about what time in the afternoon would you say shades are?
So I would say, probably it depends on your bedtime, if you're a morning owl or an evening lark, and we can speak about chronotypes. So it really depends on when you're planning on going to bed. But let's say that you're planning on going to bed at about 10 p.m. I would say if you're sort of going out after about sort of 4:30-ish, now is a good time to maybe start to help dilute down some of that light. But then, in the evenings, we are so bathed and saturated in light. And yes, we can speak a lot about LED screens, and they are impactful, and there's been lots of work on that, some of which haven't replicated, but many of which have. I think the bigger problem is just overhead lighting in general. We're just infused in every room that we go. And my recommendation has now been, in the last hour before bed, just turn off half of the lights in your house. We don't necessarily need all of them blazing in the last hour before bed. And when you do that, it's quite surprising how soporific and somnogenic it actually is. And I want to do the experiment, although someone beat me to the experiment and they did it. It's one of those studies when I read it, I just thought, my first reaction, and I'm just to show I'm not a big person, my first reaction was, oh, I'm so jealous.
Oh, yeah.
I was like, oh, I wish I'd done that. And then I just thought, this is a brilliant paper, I can't wait to teach it. They took a group of people, they looked at their habitual amount of sleep that they would typically get. And these people were getting sort of 7.5 to 8 hours. And they would ask, when are you going to sleep? And sort of most of them would go to bed like 11 and then sleep through till 7. And then they took them out of that typical, modernity environment, and they took them out to the Rockies, and they had sleep tracking equipment on them, and they took them there for several weeks. And there was no electricity whatsoever, not even a torch, not even a headlamp from a car, nothing. And then they looked to see what changed. The first thing was that these people went from sleeping, an acclaimed 7.5 or 7 hours of sleep, that was their norm. It was actually just below 7, saying that was fine, that's all I needed. To then actually, when they had no watches, they didn't know when to wake up, no alarm clocks. They ended up sleeping closer to 9 hours a night, which is what we typically see when you saturate sort of people away from, or dislocate them from modernity.
So would you say that's a good sleep duration?
So I think somewhere between 7 to 9 is what we recommend. But I think when you do this in healthy young people, and these were healthy young people, they seem to acclimate to a sleep amount that was somewhere between sort of 8 to 9 hours of sleep. So I think it's good evidence that, you can look at how hunter-gatherer tribes were sleeping, and we've studied, these people, and they actually sleep in a strange manner, and we can get back to that. And people have tried to use them as the gold standard as to how we should be sleeping.
They're a lot more active, and things are so different,
I don't think it's
right?
a good control. I think we should say, let's take modern human beings, and let's just take them out of all context of modernity, and let's see how they're sleeping. Let's just sort of put them on an ad lib buffet of sleep, and they can just sleep as much as they want. They're not told when to wake up and sort of when to go to bed. And they seem to sleep what we now think of as a natural amount, which is somewhere between, if you look at the distribution, 7 to 9 hours.
And these are younger individuals, sure.
Yeah, so, and we can speak about, and I hope we speak about sleep and aging. But what was also interesting is when they slept, not just how much they slept. They started to go to bed earlier and earlier and earlier, and they started to wake up a little bit earlier and earlier. And their total duration of sleep expanded, but where that expanded amount of sleep was positioned on the 24-hour clock was dragged back, because they weren't influenced by these cues of, too much daylight at night. Temperature is another one that I'd love to speak about too. But what's fascinating is that when you look at hunter-gatherer tribes or these experiments of sort of true nature, the natural middle point of sleep, the middle phase sort of time of the 8 to 9 hour sleep phase came somewhere between midnight and 1 p.m. And I often ask people this question, you know, have you ever thought about what the term midnight actually means? Mm-hmm. You know, it means the middle of the solar night, which is the time when most of us should be in the middle of our sleep phase. But now, in the 21st century, we've gone through the agrarian sort of, push into the industrial era and now into the digital era. Now midnight is the time when we maybe check Facebook for the last time or think about sending that last email. So not only has the duration of our sleep decreased through the influence of the modern times, but also when we're sleeping has been dramatically shifted too.
Right. I know I've made some changes a few years ago to my place where I was telling you I have Philips Hue lights that turn on red light, and they come on actually quite early. They come on around 5 p.m. In fact, when we have visitors, they start to go crazy when sunset and it's like red and they're like getting sleepy and they're like, it's like, why is it so dark in here? Can we turn the lights on? And it's like, no, because that's what you're supposed to be getting sleepy right now. You're supposed to be getting, it's 6 o'clock, 6:30. Well, depending on what time of year it is, the sun setting, you should be getting sleepy.
Yeah, it's one of the
phenomenal.
key triggers.
It really works.
Temperature is the other key trigger that I think that's probably, in the past 3 years, that's what we've really understood is that temperature is as powerful a trigger of sleep organization and sleep depth as light is.
And sleep depth.
And sleep depth as well. Oh. So what typically happens is that for you to fall asleep and stay asleep, your body needs to drop its core temperature by about 1 degree Celsius or about sort of 2 to 3 degrees Fahrenheit. And that's the reason that you will always find it easier to fall asleep in a room that's too cold than too hot, because the room that's too cold is at least taking you in the right thermal direction for good sleep. It's dragging your body down into a cooler realm. Mm-hmm. And when you look at these hunter-gatherer tribes, the San in Namibia, you can look at them, whose way of life hasn't changed for thousands of years. They don't go to bed necessarily as immediately as the sun goes down. They usually go to bed maybe sort of 8 or 9 in the evening, several hours after sundown. But when they do really start to go to bed is when the temperature drops. As the sun drops, the ambient temperature remains for a little while, and then it starts to drop too as the land cools and the ambient temperature cools with the land because darkness has ensued. That seems to be a thermal trigger for them getting sleepy and falling asleep. Then when you look at when they wake up, they typically wake up 15 to 20 minutes before dawn. So it's not light that seems to be necessarily the trigger instigating the awakening. It's actually the rise of temperature.
And that's on a circadian rhythm, right?
And that's on a circadian rhythm. So what is entraining us to our natural sleep rhythms is both temperature and light. So this comes back to our modern homes where we go into offices and we don't necessarily have the rising warmth of the day to activate us because we're set at 70 degrees. And then we go home and our thermostats are set at 70 degrees again, or whatever your standard temperature is. And we don't get the thermal cue through our bodies to say it's time for sleep. So no wonder our sleep is worse. And if you manipulate people's core temperature, and you can do this through showers, hot baths, you can do it through saunas, but there was a great experiment where they essentially designed what it looked like a kind of a wetsuit. And throughout the wetsuit were all of these plastic veins running through them. And the researchers were able to exquisitely control through water at different temperatures the temperature of any part of your body. So would I want to warm your hands and your feet? Or would I want to warm your core? And so what they were able to do is, these people, talk about being stripped of your dignity. You get into this like wetsuit, you zip it up and you say, right, I'm off to bed, in you go. And then they would manipulate core body temperature exquisitely. And lo and behold, when they dropped the core body temperature, they were able to induce sleep quicker. And the amount of deep sleep what we call slow wave sleep, which is deep non-REM sleep, or stages 3 and 4, also called slow wave sleep because of these big, powerful, slow brain waves. That deep, rich non-REM sleep was increased somewhere between about 10 to 20%, which is non-trivial.
Wow.
Then they said, well, this is in sort of, young, healthy people. What about people with insomnia and people who are older? Because older people struggle with sleep, and of course, insomnia. And they were able to get even greater mileage out of the thermal manipulation with those cohorts too. So I think it's a very interesting intervention possibility to try and augment and manipulate human sleep.
So do you think those things like the chili pads that are out there, you think those can potentially help deep sleep?
Yeah, I think, I don't know of any data from them yet. All I know is the experimental data that we've looked at, with manipulation of body temperature. They did this in rats a while back, by the way, which is that they would warm their paws. And when they warmed their paws, the rats fell asleep quicker and stayed asleep. And you think, hang on a second, you just told me that you need to cool the body, but you're talking about warming them up.
Right.
And this is the reason why probably saunas work, hot baths work, and showers work, for the opposite reason that most people believe them to work. You think, I get out of a hot bath and I'm nice and toasty, I get into bed and I fall asleep faster. That's not true. What happens is that you get into the bath, you get massive vasodilation, all of the vessels open up on the surface of your skin. That draws, it almost charms the blood out from the core of your body to the surface. And your skin and your hands and your feet especially act like these wonderful thermal radiators, and they dissipate the heat. So you get out of the bath and your core body temperature actually plummets. And that's what you need for good sleep. And I suspect it's the reason that saunas. I mean, I think you've had experience here too.
Definitely. It definitely affects my sleep. And going from a sauna into an ice cold shower and then doing kind of like going back and forth really helps sleep. And I've used that also going to other countries and getting in the sauna and going in the cold shower and then back in the sauna.
Triggering
it helps with my jet lag.
Yeah.
I mean, it's an N of 2 because my husband experienced the same thing. But, there's definitely something there. And what you're saying absolutely happens. The sauna increases vasodilation, blood flow goes to the skin, and so dissipation of heat. That all makes perfect sense. So hot baths.
Very quickly, just grab a quick mouthful of water.
The hot baths and hot showers are good before bed.
Yeah, and I'll just mention, I think that one thing that's, I think, fascinated me, though, about the benefit of exercise. So exercise also has a really nice, powerful benefit on sleep, although it's a two-way street, and remind me to talk about that in a good way. But something else has occurred to me with saunas too, and I was thinking about this because I think, I know that you're a fan, I think you've mentioned this before. One of the ways that you can induce sleep is that you can increase a lot of the immune factors, things like cytokines, things also like TNF alpha, you can, or BDNF. IL-6? IL-6, IL-1 even more so, but IL-6 is part of that equation too. We've known this for some time, that if you infect an animal, it will create an immune antibody response, a cytokine cascade. Those cytokines have a direct communication pathway into brain structures, including things like the hypothalamus, which regulates sleep. And it's that immune cascade that is actually a trigger for dialing up the amount of sleep. So when animals get sick, just like when humans get sick, the thing that you want to do is just curl up in bed and go to sleep. And in fact, you get sleepier as a consequence of being infected. Why is that? The reason is because there is nothing better. Sleep is the Swiss Army knife of health, that no matter what the ailment,
that's so cool. I didn't know
there is something more than likely in the armament of sleep's toolbox, sort of, as it were, that will deal with that. And so, and I promise I'm not going off on a tangent here. So the idea is that these immune factors are sleep instigating. They are
this is awesome.
Sleep sort of, they're somnogenic, somnus, sleep-genic, increased genesis improvement. So what I've been thinking about is whether or not the sauna, the benefit of the sauna, is both thermal, but is also by way of this powerful immune pathway.
It does.
You get this
That's
and I've read some of the studies, and I'm blanking on his name. You will probably remember his name. They've looked at sort of some of the essentially sort of the sauna-induced immune responses.
Yeah, so that Charles Raison's been doing that work.
Yeah,
yes.
Thank you, brilliant. Yeah, so I've read some of Charles's papers.
Yeah, we had him on the podcast. He was talking about how the sauna induces IL-6.
Yep.
And some of that stuff, and the same thing that happens with exercise.
Yes. So that's why I mentioned exercise, right. Which is that I think.
Wow, that's so fascinating.
So now we're all starting to sort of realize how the sleep system is augmented. One of those paths, is light. The other is darkness. The other is temperature. But here's a fourth one: the immune system. Mm-hmm. And we know that you can inject, some of these cytokines into animals, and you can almost induce sleep. It's that powerful.
That's so cool.
So now I'm starting to think, I wonder if some of the sauna-based benefits and some of the exercise benefits, because when you exercise, you also typically get some of these pro-inflammatory cytokines that sort of get released to perhaps deal with some of, the essential, the stress. And, I think we've both spoken about this, that
so is that why, if you're exercising a lot, you do seem to require more sleep, or you sleep more?
Well, we don't know that, but that's my current theory, which is that,
So are you going to test that? That's awesome.
Yeah, we're going to test it. So we've just actually been looking at a study, not with exercise or with saunas, but we've actually been looking at sleep and pain. And when you deprive people of sleep, you get a chronic release of these pro-inflammatory cytokines, which is not a good situation. Acute, great, somnogenic, good for the body, but chronic long-term, and we're starting to piece together a brain-body-sleep-pain interaction, which I think we haven't published this yet, but should have marked implications for the hospital environment, because the one place where you do not get a good night of sleep, where it's architected against the night of sleep, is the one place where you need sleep the most, and it's usually the one place where you are in pain the most. And I want a revolution to happen regarding sleep in hospitals, and I'm desperately trying to work with folks, for example, in the NHS in the United Kingdom, National Healthcare System there. I would love to work with any hospital system in the US to solve this crisis, I think, of sleep in the hospital environment. But to come back to your point, this is a great experiment to do. Is exercise-induced acute inflammation and is sort of, heat shock sensitive, induction of immune responses by way of saunas or hot baths, are those a pathway triggering good sleep? And if so, can we find novel therapeutics for,
I'll put you in touch with Dr. Jari Laukkanen too. He's in Finland. He's the leading researcher on saunas. And
has he done some of the stuff on longevity?
He's the guy doing all the longevity, Alzheimer's disease, cardiovascular disease. And he's a friend of mine as well. So I'll put you in touch with him, because that would be really cool if you guys could.
If we can start tracking their sleep, and see that perhaps, and you can sort of put this into a statistical sort of triangulation, which is called a mediation analysis, and you could see, what's causing that longevity benefit, because we know, for example, that the shorter your sleep, the shorter your life. That short sleep predicts all-cause mortality. It's also probably one of the most significant lifestyle factors determining whether or not you'll develop Alzheimer's disease. And all of these things I know have been linked to, for example, sauna use, which is longevity, decreased susceptibility to development of dementia and cognitive decline, is part of that. I'm not trying to say it's all about sleep. But part of it
really,
sleep,
one of my major interests is aging, increasing health span, as well as performance, without the trade-off. Yeah. And every time, I always come back to sleep. The studies, it's just constantly coming back in my face how important sleep is for all of those things.
And it's the superordinate lever that transacts all health benefits. It's the tide that rises all of the health boats. And I think it's wonderful that folks, here in Silicon Valley are going after, individual pathways of disease, trying to manipulate, immune pathways, or trying to manipulate mTOR for sort of, longevity. But I think what's been missing in this equation is that there is, an Archimedes lever here. There is one superordinate node that if you pull that lever, all of the other pathways are instigated and activated, and that superordinate node or lever is this thing called sleep. There is no physiological system that we've been able to measure that isn't wonderfully enhanced by sleep when you get it, or demonstrably impaired when you don't get enough.
Right. I kind of wanted to go back, because you were talking about the effects on how the immune system can be, what did you call it? Sleep, when it induces sleep.
Oh, it's somnogenic.
Somnogenic, yes. How it's somnogenic. So interesting. I had no idea that the cytokines were responsible for that, and it makes perfect sense. I mean, so anyways, but also the opposite is true, where sleep also affects the immune system, or lack of sleep also,
it
right?
Does, yeah.
And that is something, that's your immune system's the first line of defense against pretty much everything, right? Cancer, viruses, bacteria.
Yep.
And I think in your book, you were talking about the effects on some studies on natural killer T cells.
Yeah.
I mean, I was just like blown away by some of the numbers.
This is a frightening study. So it was done by my colleague Mike Owen, and you take a group of individuals, and you're not going to deprive them of sleep for an entire night. You're simply going to limit them, restrict them to 4 hours of sleep for one single night. And then we're going to measure the amount of reduction in natural killer cell activity. So just to take a step back, natural killer cells are a critical part of your immune defense arsenal. And today, both you and I and everyone listening to this podcast, we all have cancer cells that have emerged in our bodies. But typically what prevents those cells from becoming this disease that we call cancer is in part these natural killer cells. So what you wish for is a virile set of these sort of immune assassins, these sort of James Bond-like, that they will annihilate these foreign organisms. You want a virile set of those at all times. So take a group of healthy people, limit them to 4 hours of sleep for one night, and what you see is a 70% reduction in natural killer cell activity, 70. That is an alarming state of immune deficiency, and it happens quickly, essentially, after one bad night of sleep. So you can imagine, the state of your immune system after weeks, if not years, of insufficient sleep. And it's now the reason I think that we probably are finding at the epidemiological level significant links between short sleep duration, not getting enough sleep, defined as 6 hours or less, and your risk for the development of numerous forms of cancer. Currently, that list includes cancer of the bowel, cancer of the prostate, cancer of the breast. And the link between a lack of sleep and cancer is now so strong that recently the World Health Organization decided to classify any form of nighttime shift work as a probable carcinogen. So in other words, jobs that could induce cancer because of a disruption of your sleep-wake rhythms. Okay. So, that's it, the immune system and cancer, but it doesn't stop there as well. We know another great study done by Eric Prather, who is over at UCSF, another good colleague of mine. He did this brilliant study that I write about in the book. He basically measured the sleep of a group of healthy people for a week before using these wristwatches that are accurate. And then he quarantined them in a hotel, in a set of hotel rooms. And then he proceeded to stuff up their nose, squirt up their nose, rhinovirus, essentially, a flu virus. And then he quarantined them for a week, and he measured how many of them became infected. And he was measuring all sorts of stuff. He collected every ounce of snot that they blew out of their nose, all of the mucus, everything. And what he found was that if those people who were getting 5 hours of sleep or less in the week before they came in and were infected, relative to those who were getting 7 hours of sleep or more, those people who were getting 5 hours of sleep in the week before they got infected were 4 times more likely to end up developing the flu than those people who were getting 7 hours or more. The final nail in that sort of immune coffin for me is a study that was done by Ev Van Carter, who's a wonderful endocrinologist. And I'd love, by the way, to speak about sleep and diabetes and glucose regulation too. She's done some great work there. But she did a great study. She looked at the amount of sleep that you were getting in the week before you get your flu shot. And what she found is that if you're getting sort of less than 5 or 6 hours of sleep in the week before you get your flu shot, you only produce half of the normal antibody response, rendering that flu shot largely useless. Right. Which stuns me that, and here's where technology could revolutionize healthcare. What if Kaiser, had access to a sleep tracker or had its own sleep tracker? And Kaiser, for those not familiar, is a healthcare provider here in the United States. But what if, any healthcare provider or system in any country had access to your sleep in a non-Big Brother way, and it was tracking your sleep, and through an app, it would say, hey, you've had a great week of sleep. this week in December or this week in November, now is the time to come and get your flu shot. I've listed out 3 appointments, just tap on the one that you want. Or it says, look, I know that you scheduled yourself for a flu shot. You haven't quite got the good sleep that you need this past week. Let's try again next week. And if you get the sleep next week, then you give them access to getting the flu shot. Because otherwise we're wasting money. And the flu, costs the United States, the flu season costs the United States about $10 billion directly in terms of healthcare burden. Even if I could nudge that by just 1 or 2% by understanding people's sleep and helping architect a system that co-opts around sleep time and management, we could save hundreds of millions of dollars to the US economy.
Wow. Speaking of the flu, I think I even told you this in a previous conversation, I almost never get sick. Maybe once a year I'll get a little runny nose for a couple of days, and I've got a really good immune system, generally speaking. But this last year I had a baby, and along with having a baby comes sleep deprivation, and there's absolutely nothing I can do about it. I mean, you have to wake up multiple times to feed your baby.
Yeah.
And so that's what I was doing. And I got the flu, I got a cold. I was sick every month. It was crazy. I've never experienced, of course, my baby luckily was getting all my antibodies and didn't get sick, thankfully.
Yeah.
But it was completely connected to my sleep. Yeah,
it's the same wisdom that mothers would sort of say. They'd speak to you and you're getting sick a lot. Are you sleeping enough?
Yeah.
And I've often thought that people like me, sleep scientists, all I'm really doing is putting the data behind everything that your mother and Shakespeare ever told you about sleep. I'm just putting data there. They knew it all long before the data came along. But you see that exact same thing in parents. Sickness is rife in those early years. Mm-hmm. You see it in medical residence. I think a friend of yours who I enjoy listening to a lot, Peter Attia, was saying this about when he was in medical residency. And you see this in residence too. Sickness rates, increase dramatically. There is weight gain. Their diabetic profile, in terms of their ability to manage glucose, becomes markedly impaired. We know that testosterone in men plummets when sleep gets short. In fact, men who are sleeping 5 hours or less will have a level of testosterone which is that of someone 10 years their senior.
Wow.
Which, in other words, a lack of sleep will age a man by a decade in terms of that aspect of virility and wellness.
How quickly does that happen? Do you know? Is that
So you can see that within almost days once you start to dose people on that. It comes about quite rapidly. You can see hormonal change. I think that's one of, if there is a major axis within the body that is altered by sleep, it is the hormonal axis. I think that principally through the root of the autonomic nervous system, that is the lens through which almost all sleep and sleep deprivation effects can be viewed. And I'm just starting to write up a theory paper about this, which is an encompassing theory about sleep deprivation within the human brain and the body. And I think there is a common central dictating governing pathway, which is the autonomic nervous system, through which there is a manipulation of many of the hormone systems, which then give rise to the whole host of deficits that we see by way of a lack of sleep, which then ultimately, through chronic exposure of sleep loss, give rise to all of the diseases that we know are associated with a lack of sleep. And every single disease that is killing us in the developed world has causal and significant links to a lack of sleep.
One that I'm particularly interested in is Alzheimer's disease.
Yeah.
It's something that I've been researching for a while. I'm about to get published, thankfully, soon.
Congratulations.
Soon. Thank you. But
is this a review paper?
Yeah.
Oh, please send it
and it
to me.
happens to do with a gene called ApoE4. And I found out that I have one copy of this allele. And when I found that out years ago, I was like, it's probably the biggest risk factor for late onset Alzheimer's disease besides age.
Yeah, so I think one of those alleles, it's about sort of a 2 to 3-fold risk.
2 to 3-fold.
If you have two of them, it's like an 8 to 12.
Yeah, it's pretty bad. And a quarter, 25% of the population in the United States has at least one allele.
Yeah.
So it's definitely, and just because you have it doesn't mean you're necessarily going to get Alzheimer's disease.
That's right.
Not everyone with it has it, but there's huge interaction with, diet and lifestyle. Probably the biggest lifestyle interaction with this gene is sleep.
Yeah.
And so that was that was where I became very interested in how sleep affects the brain and how it affects, Alzheimer's disease and all that. So I'd love to kind of talk a little bit about that.
Yeah, so we've been doing a lot of this work. We have a large research program here at UC Berkeley at the Sleep Center that is devoted to aging and Alzheimer's disease. And we've been very fortunate to get many grants from the NIH here to study this. I think the story is fascinating because it's a bidirectional relationship between sleep and the pathology that we know is associated with Alzheimer's disease. So in Alzheimer's disease, there are at least 2 protein culprits that we believe are underlying the brain pathology that seems to create this thing called Alzheimer's. One of them is a sticky toxic protein called beta amyloid that accumulates in these clumps outside of brain cells, and that creates these amyloid plaques that seem to be correlated with your disease risk and disease severity. The other is a protein that we know probably less about, which is a protein called tau protein, and that sits inside of cells, and it creates a support structure for communicating and funneling many of the critical ingredients up and down your nerve cells to keep them in rude health. And during Alzheimer's disease, that protein starts to sort of fall apart and dismantle, and you get these sort of tau tangles, and the structure of the nerve cell and its ability to transport all of the ingredients that it needs to operate starts to collapse and fail. It's like a tunnel collapsing down. So one of the discoveries that we made back in 2013 was that I was looking at the distribution of this sticky toxic protein called amyloid in the human brain. And what's fascinating is that it doesn't build up in the brain homogeneously. Amyloid builds up in some parts of the brain far more severely and early in the course of Alzheimer's disease. And other parts actually remain completely invaded by this thing called amyloid. In fact, parts of the motor cortex, for example, or parts of the visual cortex, you see almost no amyloid in our Alzheimer's patients. And that's probably the reason why their motor functions and their vision is unchanged. But one of the earliest places where beta amyloid builds up and then builds up most severely in late stages is back again in that medial prefrontal cortex that sits right there in between the eyes. Why was I interested in that? I was interested is because when we were doing studies where we would map with all of these electrodes over your head, we would map the deep sleep that you were having. And we could do some clever mathematical modeling of those deep sleep brainwaves, and we could try to triangulate where was the electrical epicenter of those electrical deep brainwaves of deep sleep. And it seems as though they come from all over the brain, but the principal epicenter that generates your deep sleep sits right there in the middle part of the prefrontal cortex. It is exactly the same part of the brain that accumulates toxic beta amyloid protein. Then we'd done studies, and other people had done studies before us, that demonstrated as we age, our sleep gets worse. But not just any type of sleep, especially that deep quality of sleep that we know and we spoke about is critical for saving and learning and retaining new memories. So all of these jigsaw pieces started to get put together in my head, and I thought, we need to do some studies. Is it possible that the amount of amyloid that you have in the brain in this sleep-generating center, it should directly predict the deficit in the amount of deep sleep that you get? If it predicts the deficit in the amount of deep sleep, it should predict the deficit in your ability to hold on and retain new memories, which is a hallmark cognitive feature of Alzheimer's disease: difficulty learning, difficulty retaining. So we did the study, and that's exactly what we found. The more beta amyloid that builds up in this central frontal part of the brain, the less the deep sleep that you have. The less amyloid-related deep sleep that you had, the more forgetful you were the next day rather than the more that you remembered. So this was the first part of the Alzheimer's sleep equation, which is that Alzheimer's disease attacks the deep sleep generating regions, and you have a diminution of deep sleep, which in turn blunts your learning and memory abilities, and you become more forgetful. A far more important discovery was made by another group, far more important than the one we made, which was essentially the reverse direction, which was to say, rather than amyloid sort of decreasing sleep, could sleep actually decrease the amount of amyloid that you get? And this was a discovery that was made in rats back in 2009, I believe, was the first evidence that was published in Science. And this is a colleague, Dr. Nedergaarden, who is out on the East Coast at the University of Rochester. And she made two wonderful discoveries. The first was that we've known for a long time the body has a waste sewage system called the lymphatic system. But the brain doesn't have its own lymphatic system. The lymphatic system does not penetrate the brain. So where does all of the garbage, the metabolic garbage, go that your brain cells produce? Where's the sewage system for the brain? And she discovered it. It's actually made up of a set of cells called glial cells, which are these supporting brain cells. And so she called it the glymphatic system rather than the lymphatic system. So your brain does have a sewage system, this glymphatic system. And that's the discovery that she made. Remarkable. Then, and I'm not quite sure what motivated her to do this, she started to measure how efficient that glymphatic, that waste system was when the rats were awake and when the rats were asleep. And what she found was that it's during deep sleep that these brain cells actually shrink by almost 60% when we sleep. Blows my mind. Yeah. It's almost like, all of the buildings in New York all of a sudden shrink, and it leaves these much greater, larger areas for the cleaning crews to come in and clean up all of the metabolic detritus of the city's activity during the day. That's exactly what happens during sleep. And the cleaning solution is what we call cerebrospinal fluid. And through a pulsatile mechanism during sleep, you get a 10 to 20% increase in the bathing of cerebrospinal fluid through the brain, which washes away all of the metabolic byproducts that have been building up. One of those metabolic byproducts is beta amyloid. And in fact, if you deprive those rats of that deep sleep, you immediately get an increase in toxic beta amyloid. So now we've linked these two. I'm sorry, it's a long story, but if you're not getting enough deep sleep at night, you're not giving yourself the chance for the kind of good night and sleep clean process to remove the beta amyloid. So more beta amyloid builds up. Where does it build up? Tragically, in the very same regions of the brain that generate the deep sleep that you need to clear out the toxic amyloid. So you start getting less deep sleep, so you get more toxic protein, less deep sleep, less deep sleep. It's a self-fulfilling prophecy, and it's a non-linear exponential curve. If you look at how amyloid builds up in the brain, and if you look at the trajectory of Alzheimer's disease, it is a non-linear exponential curve. It fits exactly what the sleep-dependent model of amyloid clearance would predict if you're not getting sufficient sleep. That's the reason why now insufficient sleep seems to be one of the most significant lifestyle factors determining that. Now, you could say, by the way, those studies were in rats and you deprived them of sleep for one night. What about humans? Like, surely, well, the study has now been done. Great study done out of WashU by a team of scientists there, led by David Holtzman. And they took a group of humans and they did this very clever method where they deprived them of deep sleep, but they didn't deprive them of sleep. And you think, it sounds paradoxical. I can play you these auditory tones. Now, this is not like the memory reactivation where you play a tone and then you leave the brain alone for a while. Here, I'm just going to keep playing tones to your brain, really sort of annoying tones. But I can play them at a level that doesn't wake you up, but it lifts you out of deep sleep and keeps you in shallow sleep. So what's delightful about this method is that I can selectively excise one type of sleep, deep sleep, but I don't wake you up, so there's no stress of awakening. You are asleep for the same amount of time, but the quality of sleep is decreased.
Can street noise do that?
We don't know. Although I will come back to that when we speak about, hopefully, sleep appetite regulation, sleep glucose regulation, and sleep in low socioeconomic
It's a little terrifying.
cultures. And I think it's possible there's a link. I think there's other factors that link poor sleep in low SES socioeconomic backgrounds. Is noise pollution one of them? I actually think it is, untested as yet. But what they did with these human participants, they selectively removed deep sleep while keeping them asleep. So total sleep time was not changed. And then in the morning, they woke them up, they rolled them over, and they did a spinal cord puncture, a lumbar puncture, and they measured the cerebrospinal fluid that was percolating within the spinal cord, which also goes around the brain. And you can measure the amount of beta amyloid, which is a reflection of perhaps how much amyloid is there within the brain. After one night of essentially a loss of deep sleep, you saw an immediate rise in the amount of beta amyloid. So it is a causal manipulation that insufficient sleep in rodents and in humans will lead to a rise in beta amyloid.
Yeah. I think it was like 25 to 30% increase.
It was.
It was, yeah, it's definitely. Yep. So, of course, that's all I could think about the past 9 months.
During the, yeah.
With the buildup of amyloid. The
problem is, I would tell you that's the last thing you should think about. Try not to worry too much about it, because it's not to say to diminish the loss of sleep, but simply to say that worrying about it is not going to do you any good. But how do you tell that, especially to people who, have one ApoE allele,
right.
ApoE4, allele. What I would also say that's important for people, if you know your ApoE status, and if you are ApoE4, be mindful of snoring as well, because people who are ApoE4 positive, they also have a significantly elevated risk of a sleep disorder that we call sleep apnea, which is sleep disordered breathing, which is heavy snoring and then a cessation of breathing entirely. And then you gasp and you wake up again. Heavy snoring, sleep apnea is a killer. It is an outright killer. It increases your risk of basically everything you don't want: cardiovascular disease, stroke, diabetes, and obesity. It also increases your risk of immediate death through higher risk of car accidents. But one of the other problems with sleep apnea is that you don't get the amount of deep sleep that you need, and you have hypoxic damage. Because you stop breathing, your oxygen saturation goes down. You get hypoxia damage, particularly in a region that is most sensitive to it in the brain, which is, drumroll, the hippocampus, the very same memory structure that is attacked in Alzheimer's disease. So now you can see this, why I appeal for this sensitivity and this danger to sleep apnea, because if you are ApoE4, you're already at high risk of Alzheimer's disease. You need to pay attention to your sleep. If you start snoring and you have sleep apnea untreated, you will get less deep sleep. So you're compromising the thing that you need to try and lower your amyloid risk to begin with, because you're going to build up that amyloid, because you're not going to get the amyloid clearance elsewhere in the body, for example, in the liver. And then worse still, the part of the brain that is attacked severely by Alzheimer's disease and atrophies, which is the hippocampus, which is why memory fades, is a part of the brain that is damaged when you stop breathing because of oxygen desaturation. So as an appeal, even if you are not ApoE4 positive, but you are snoring or you know someone who is snoring, go and see your doctor and get a sleep apnea test. It is potentially life-saving.
I actually had a sleep apnea test because of my night awakenings. I didn't know. I was like, maybe I have apnea and I couldn't. Yeah. And so I'm having this terror. And of course, that wasn't it. I didn't have sleep apnea. But I didn't know about the connection between ApoE4 and sleep apnea. That's terrible.
Yeah,
because
it's quite a dramatic.
Yeah,
and when you combine those two together,
right.
it's a real. I mean, it's gasoline on an already.
People with ApoE4 also don't repair damage in their brain as well as people with ApoE3. So if you're talking about hypoxic damage in addition, there's sort of just this potentially compounding effect.
And I think that's that's part of the reason. I mean, I have some family members that have been associated with Alzheimer's disease. One recently passed away, and it's been a big motivation for me personally. I started, 20 years ago. My PhD was looking at people with degenerative dementias. That's how I actually got into sleep, because I was seeing these sleep abnormalities, and I'm so desperately trying to find ways to help and to combat that incredible epidemic of dementia. Mm-hmm. And that's why we've started to try and develop things like electrical brain stimulation methods to try and help actually augment human sleep and electrically supercharge sleep, as it were, to see if we could give back some healthy quality of deep sleep to patients who are aging or those with dementia, can we essentially amplify the amount of deep sleep? And in doing so, can we salvage aspects of learning and memory? But better still, could we actually start to increase, the amount of glymphatic clearance of beta amyloid? Now, I suspect that when the disease is in play and you've been diagnosed in those late stages, I don't know how much sleep is electrically charged, even as it may be, could help. What we're now trying to do in our studies is actually retrospectively find out, is there a particular decade of life or decades of life when a decline in sleep makes you most susceptible to then developing a lot more amyloid later in life? In other words, we're trying to now identify these vulnerability windows during the lifespan. The reason I want to do that is if I can scientifically convince myself of a knowledge base of vulnerability sensitivity to insufficient sleep. My guess is that it's just across the lifespan. It gives me a chance to know where's the inflection point of not late stage life treatment, but early life prevention. Because that's what medicine has to do right now, I think. We've done a good job at extending lifespan, but a miserable job at extending health span. Lifespan is probably about treatment. Health span is probably about prevention. Sleep needs to be part of that discussion. And sleep is usually absent in many of these conversations for either lifespan or health span, despite it having a demonstrable impact on both. But my hope is that to be able to find that sensitive time when your risk for Alzheimer's development by way of insufficient sleep is present, that's where I go in and start augmenting your sleep with electrical brain stimulation or other methods that we're trying to develop as well.
I think, at least with the ApoE4 positive individuals, by the age of 40, the amyloid plaques start to really...
That's right, yep.
So to me, it would seem that before 40 and certainly when you hit 40, you better have your sleep optimized.
And I would say before, we can see the decline of deep sleep occurring in people in their 20s. That's when your deep sleep starts to decline.
Wow.
Which is, frightening, isn't it? It's sad. And at that point, it's in the male. By the time you're 50 years old, you've lost about 50% of the deep sleep that you were having when you were a young teenager. Wow. By the time you're 70%, there's only about 5%. Sorry, by the time you're 70 years old, there's only about 5% of your deep sleep left that you had when you were young and healthy. By the time you're 80, we almost can't detect any of these deep sleep brainwaves anymore.
Do you know if there's changes in the way your core body temperature regulates with age as well?
There is. So what happens with age is that your circadian rhythm that we spoke about before, your circadian rhythm that we spoke about before, which in healthy people is nice and high and peaking during the day, lots of activity, and then drops down at night, lots of inactivity, lots of deep sleep. That sinusoidal wave starts to flatten out as someone has compressed it as we get older. So our circadian rhythm gets weaker. So we feel sleepier during the day and not as alert as we used to do. But we don't feel as though we are as sleepy at night. We're more awake at night because our circadian rhythm is blunted. And so I think that's another area for aging intervention is how can we modulate the circadian rhythm? And it turns out that it comes back to light. So one of my colleagues in the Netherlands, Urs van Summeren, did a great study where he installed circadian regulating light in an elderly care home, in a home where you care for the elderly. And many of them had cognitive decline, and he's now done some of these studies with people with Alzheimer's disease in some of these care homes. And when you start to create appropriate lighting in the internal environment in these homes, which if you go into them, and I used to go into them all the time during my PhD, these sort of care homes, and I would be testing my patients and seeing my patients there, they were grim environments with dim light, and these patients never got outside. They rarely had a window. And Urs van Summeren, the scientist in the Netherlands, he was able to really produce this strong bout of light during the day inside the care home, and then drop out that light in the evening. And he regularized the light, and he improved the circadian rhythm, and he improved cognitive outcome measures.
Wow.
Cognition got better in these Alzheimer's patients.
That's cool.
Now, you can look at that same manipulation, that same lighting hack at the beginning of life. So in the neonatal intensive care unit, what we used to have when we go in there, you just have constant light on all of the time, dim light on 24 hours a day, which prevented those infants getting the signal of a regulating 24-hour light-dark cycle. If you regularize light in the neonatal intensive care unit, so light during the day, darkness at night, in these studies, what you see is basically almost a 50 to 60% increase in oxygen saturation within the blood of these neonates in the intensive care unit. Weight gain increases dramatically, and they end up exiting the neonatal intensive care unit about 5 weeks earlier than they would otherwise. Circadian regulation of sleep leads to better health outcomes. It does so in neonates, it does so in the elderly. So I think there's all manner of sleep possible interventions that we can think about across the lifespan when it comes to modifying disease risk at any stage of life.
Yeah, and I think, at least as far as I've understood from our conversation thus far, some of the main things for prevention in optimizing your sleep really are preventing that emotional stimulation, that anxiety inducing, particularly a few hours before bed, bright light exposure early in the morning, and then not having the bright light exposure, about 4 hours before bedtime, and then the cold, like having your body temperature go down. So, whether that's through something like, having a hot bath or a hot shower, or even possibly the chili pad, which I'm going to actually experiment with.
Yeah.
Because now I've been using this Oura ring that I've been tracking my sleep. By the way, do you know how accurate, so it tells me in my app the light sleep, the REM sleep, and deep sleep. And I know there's nothing going in my brain measuring any sort of brain waves. Mm-hmm. So it must be movement, right?
I won't say specifically, even though I know the folks at Oura, and I know the folks at almost all of the sleep tracking companies. Most of them right now use a combination of your heart rate, which you can pick up through the pulse waveform, either on the wrist or on the finger, or if it's a bed sensor, through the heartbeat as well as respiration. And they'll use a combination of those things together with movement to try and stage your sleep. Right now, without naming, I don't think there's anyone that is necessarily better than the other. At least none of them have published scientific evidence. We sleep scientists have actually looked at these devices relative to gold standard, what we call polysomnography, which is essentially like doing a sleep study. If you were to, here at my sleep center, we've got all of this equipment. You look like a spaghetti monster with electrodes on your head.
I don't know anyone can sleep with that on.
Yeah, I know. But we can measure that sleep with high precision, high fidelity. That's the gold standard. And when you compare these sleep trackers, unfortunately, they're not quite accurate. They either overestimate or underestimate sleep onset latency, how long it takes you to fall asleep. They either overestimate or underestimate the amount of time that you've been awake. Sleep duration may not be bad with some of them, a total sleep duration. But once you get into the sleep stages, that's where things become more inaccurate. Their ability to separate non-REM from REM is getting better. It could be in the region of sort of 60% accuracy, possibly lower. But right now, we're not there yet. Will we be there in about sort of 4 years' time? I actually think we will be.
Because that's what I'm really interested in, the deep sleep, obviously.
But also I would say REM sleep too. I think REM sleep takes a back seat. It's sort of, a bit of a neglected stepsister in the sort of sleep conversation. REM sleep, we found, serves all manner of different functions, one of which is emotional first aid. It's incredible for a palliative emotional benefit. It's not time that heals all wounds, but it's time during REM sleep that provides emotional convalescence.
I guess that would also then be important to help you sleep better, because if you are managing your emotions better, you probably have less anxiety.
Correct. Exactly. But also REM is for the body too. It seems to regulate cardiovascular function. So REM sleep is critical.
Oh, really? Is REM what's important for the lowering the blood pressure?
No, it's during deep sleep that you get this lowering of blood pressure, and we've got some data right now that we're about to publish that deep sleep provides actually a homeostatic recalibration of blood pressure. What do I mean by that? If I measure your blood pressure before sleep and then after sleep at a matched circadian time, so we remove the circadian fluctuation, of which there is a large one, to your systolic blood pressure, but we match it, and so the only thing that's different is the quality of your sleep. What we've discovered firstly is that the amount of deep sleep that you have measured in these big delta slow waves during deep non-REM sleep, that predicts how much of a drop in your systolic blood pressure you will have in the morning relative to the evening, as if deep sleep provides a recalibration of the cardiovascular system. If you're having higher frequency brain waves that are not like the deep sleep, that's what we call unrestorative sleep. If you have a ratio of very little deep brainwave activity and a lot of high frequency wake-like brain activity, that what we call a delta-beta ratio, that predicts very bad cardiovascular outcomes. That if anything, your systolic blood pressure is even worse after sleep than it is the night before. And what we found is that during aging, now we looked at this in healthy people, then we replicated it in older adults, and we found that the older that you get, the less deep sleep that you get, the more sort of wake-like or faster frequency brainwave activity, which isn't good during deep sleep. And that accurately predicts the cardiovascular dysfunction that we see in aging. So we now think we understand in part why poor sleep is linked to poor cardiovascular outcomes. One of the benefits of sleep is that it resets cardiovascular tone, and particularly systolic tone. It doesn't stop there. There's lots of other benefits, heart rate drops, etc. But REM sleep also seems to have this strange function where you go through these cycles where you get a massive activation of the cardiovascular system, and then it falls silent, and then a massive escalation again. And you get this really remarkable increase in heart rate variability. And heart rate variability has been used as a metric of health outcome, that if you have high heart rate variability, it's very good. It predicts lots of health outcomes. That's what you get during REM sleep. So we should be careful not to think of everything being all about deep sleep. It's about all stages. Every stage of sleep that we have ascribed a function to, which makes sense. You know, during sleep is the most idiotic of all things in terms of a creation from Mother Nature. You know, you're not finding a mate, you're not reproducing, you're not eating, you're not caring for your young, and worse of all, you're vulnerable to predation. So on any one of those grounds, sleep should have been strongly selected against in the course of evolution. The exact opposite is true. Every species that we've studied to date sleeps. What that means is that sleep has fought its way through heroically every step along the evolutionary pathway, which must mean that if sleep doesn't serve an absolutely vital function, it is the biggest mistake that the evolutionary process has ever made. And if any one of those stages of sleep could be removed because it was not important, because I want to, emphasize this type of sleep because that other sleep must not be important, I promise you, Mother Nature would have thought, I'm going to excise that stage of sleep out because you're just too vulnerable. So, but I think, in your position, of course I would be, concerned about my deep sleep, thinking about things like ApoE4 and Alzheimer's risk too. But I think the bottom line is that no matter which way you slice the sleep pie, you just can't shortchange sleep.
I just want to figure out, it'd be nice to know what environmental factors are affecting, different stages of sleep, so it's like, if I do X, then it's going to, affect my deep sleep, or it's going to affect my REM, or it's going to make me miss, for example, if I were to go to bed, let's say I usually go to bed at 9 or 9:30, and if I were to go to bed instead at 11:30 or midnight because I had some social event or something, and my circadian rhythm my circadian rhythm these days is my son wakes me up at 6 a.m.
Yeah.
But let's just say I could sleep longer if let's say I wake up at 6 a.m. but then I'm like, oh, I went to bed at midnight instead of 9:30. I'll try to go back to sleep. Like, would that be okay? Would I be able to recover something that I'm missing from the 9:30 to midnight? Do you see what I'm saying?
Yeah. So
should I go back to sleep? Should I try to go back? Or?
So you should try to go back to sleep. So you should try to get the sleep that you need.
The duration.
The duration. But so there are essentially 4 ingredients, and this is probably going to be my next book, which is essentially the 4 pillars of sleep: depth, duration, continuity, regularity. If you shortchange sleep on any one of those, you get a compromised deficit in brain and body. So depth is what we were speaking about. It really should be depth/quality of sleep. You need both the depth of those deep sleep brain waves, but you also need all of these different brainwave oscillations, these things called sleep spindles and slow waves, and the coordination between those two. It's all about the electrical quality of your sleep. So you can have the duration of sleep, you can have 8 hours of sleep, but if it's not of the right electrical quality or depth, you get deficits. But you can get lots of high quality sleep, but if you're only getting 4 hours of it, it's not going to be enough. So it's duration, depth, duration. Then it's also about continuity. This has been probably, in the past 5 years, one of the explosions in the sleep field. If you were to get 8 hours of sleep, but across a 9-hour period, because you were awake for 5 minutes here, 10 minutes here, 30 minutes here, 15 minutes here, that's very fragmented sleep, which, by the way, alcohol is another thing that will fragment your sleep very much like that. So the continuity of your sleep is poor. It's not continuous, it's fragmented. And even if you get 8 hours of sleep in a 9-hour period, but it's fragmented, versus you get 8 hours of sleep all in a nice one bout within 8 hours. So in both of those scenarios, it's the same duration of sleep. Maybe it's even the same electrical quality of sleep, but if it's fragmented and littered and punctured with many awakenings, the continuity of sleep is poor, and that's not good either. And then finally, the part is regularity. This means going to bed and waking up at the same time, no matter whether it's the weekend or the weekday. Go to bed at the same time, wake up at the same time. Those are the 4 key pillars that we know of for sleep. And you can hold any one of any 3 constant and manipulate one of them, and you get a deficit. Now, we can't quite weigh the complete, is it, this one is worth, 40%, this one is worth sort of 20%, and this, we can't yet do that, but it's very clear that those are the 4 pillars of good sleep. So I mentioned that just coming back to, though, the quality of sleep. When you position the quality of the quantity of sleep on the clock face, on the 24-hour clock face, at an inappropriate time according to your natural innate preference, and I say that specifically rather than a particular time, you will not get the same quality of your sleep. So an extreme version of this is a night shift worker, where they may get 8 hours of sleep in bed, but they are sleeping during the day, not during the night. So it's a complete reversal. The quality of their sleep is not good. They don't get the same amount of deep sleep, nor do they get the same amount of REM sleep. But let's kind of walk that back a little bit to your scenario, which is much more subtle. Let's say that my chronotype, and your chronotype simply determines whether you're a morning person, an evening person, or somewhere in the middle. About 30% of the population is an extreme morning type or a morning type. About sort of 40% is sort of neither strongly morning or evening, and about the remaining 30% is an evening type. We call them owls and larks. Now, so if you're a morning type, you like to go to bed at, let's say, like 9 p.m. and wake up at 5 or 6. If you're an evening type, you may want to go to bed at 1 a.m. and wake up at 9 a.m. the next morning. So when I'm saying the optimal position of sleep, I'm saying the optimal for your chronotype. Yeah. This is your chronotype. And by the way, it's genetic. You don't get to decide whether you're a morning type or an evening type. It's hardwired into your genes. We know the genes. It's not your fault. If you're an evening type and you're listening to this, and society, which is strongly architected against your chronotype, we reward and we favor the morning types. It is not your fault. It's not a choice. And there's not too much you can do about it. You can push and pull the system by about 30 minutes, 45 minutes, but not much more. So coming back to it, when we position that sleep on that 8-hour period, wherever is optimal for you, you will get a nice distribution. You'll get all of the deep sleep that you want and all of the REM sleep that you want. Earlier in the conversation, I said that we go through these 90-minute cycles, we human beings. It's different for different animals. You always go into deep non-REM sleep first, and then you always have REM sleep second. And that repeats every 90 minutes throughout the night. What changes, however, is the ratio of non-REM to REM within those 90-minute cycles as you move across the night, such that in the first half of the night, the majority of those 90-minute cycles are comprised of lots of deep non-REM sleep and very little REM sleep. In the second half of the night, that balance shifts, and now you get much more REM sleep in the late morning hours and very little deep sleep. The reason I'm saying this is because let's take someone who goes to bed at a standard amount of time. Let's say that they go to bed at midnight and they're going to wake up at 8. But instead, they have to wake up because they've got an early morning meeting. So they go to bed at midnight and they wake up at 6. And my question is, how much sleep have they lost? And your response is, well, they've lost 2 hours out of the 8 hour, which means they've lost 25% of their sleep. And your answer would be right in a way, but it would be wrong as well, which is that they've lost 25% of their total sleep, but they may have lost almost 80% of their REM sleep, because that's the REM-rich phase of the night. And it also works the other way around too, that if you go to bed too late, you will, so what happens is, because of the circadian rhythm, the brain has a different appetite for different stages of sleep on the 24-hour clock face. In the late evening and the early morning hours, the brain has a dietary preference for deep sleep, and it doesn't very much have an appetite taste for REM sleep. Through to the second half of the night, that's when it gets its appetite for REM sleep. So if you start sleeping at 4 o'clock in the morning and you wake up in the middle of the day, your brain has lost its appetite for deep sleep, and so it won't get much. Now, you will probably get much more REM sleep as a consequence. So you've got to be really careful. That's
so it's almost like your chronotype may even dictate, in a way, how much deep sleep you may get.
The chronotype will, if you sleep naturally and you get the amount of sleep that you want, your chronotype will probably mean that your circadian rhythm is actually shifted as a chronotype too. So you will still get, as an owl, if you get your 8 hours when you want it, you will probably get a similar sleep architecture as a lark who has gone to bed 5 or 6 hours earlier, because your circadian rhythms are 5 to 6 hours different. But you're right in the sense that owls typically try to go to bed early, but because they are designed not to fall asleep at that time, they're just going to lie in bed. Many owls think that they have insomnia. They don't. They're just not going to bed at the right time, because they get into bed and it's like a teenager whose rhythm is also shifted late. You tell them to go to bed because you've got to wake up for early school start times, but there's nothing they can do because their circadian rhythm has shifted forward in time, and it's the same for owls. So what will happen is that they will probably stay awake for a little while, then they'll get into deep sleep, but then they have to wake up at an earlier time and they will lose a lot of REM sleep. REM sleep for emotional well-being. What do owls typically experience? Depression, low mood, anxiety. So I think we're really starting to put the pieces together on that component.
And so for someone like me, I'm somewhere in the middle, like when I don't, pre-baby. Now I guess you would call a lark, because I'm going to bed at like 9. My optimal time, if I can go to bed when my son does, then it's like, if I go to bed like at 8, then I get the longer duration. That way, if I'm a little more fragmented, then I at least can make up for it somewhat. But I'm up at 6 a.m. now. If it were up to me, I'd like to sleep. I usually would wake up at like 8 a.m.
Yes.
That's my natural.
And the reason that you can probably go to sleep at sort of 9 p.m. or even 8 p.m. now is because you're chronically sleep deprived, and as a consequence, you've built up such a sleep debt that there is a lingering what we call sleep pressure in your system. But yeah, I think fighting your chronotype, we've found, comes with deleterious health consequences. Increased risk for poor cardiometabolic outcomes. Things like C-reactive protein is higher. If you look at A1C in terms of sort of your sort of a Rorschach of your blood glucose, your blood sugar, not good. If you look at your propensity for being obese or being overweight, also not great. If you're an owl and you're not sleeping according to your schedule.
Telomeres are shorter.
Telomeres are shorter as well.
So let's talk about because a lot of interesting research has come out of your lab on the blood glucose regulation front, and well, I guess more on the eating preferences and appetite.
It's the way I see it, it's all part of the energy intake expenditure system. And sleep, if you think about it like a weighing scale, between sort of energy expenditure and energy consumption. Sleep, if you're not getting it, just annihilates that balance. And we can speak about any one of those things. But I think the blood glucose story and sleep is very, very well worked out now. It started with epidemiological studies where we started to see that people who were sleeping less than 7 hours were at significantly higher likelihood of either being diabetic or going on to develop diabetes. Many of them were already in what we call a pre-diabetic state, or they had what we now call sort of metabolic disorder. And then the question became, well, is that associational or is it causal? So the next studies that happened, and this was work done back in, started in the 1990s by Ev Van Carter at the University of Chicago. Wonderful studies, took a group of healthy people, started to limit them to different doses of sleep for a week. 5 hours of sleep, 6 hours of sleep, 4 hours of sleep. And what she showed was that essentially after 1 week of short sleep, your blood sugar levels are disrupted so significantly that your doctor would classify you at that point as being pre-diabetic after 1 week of short sleep. And the way that they do this is what's called a glucose tolerance test, where you are fasted and then you are given this sickly sweet drink of glucose. And then they are measuring from your blood in the next 3 or 4 hours how quickly is your body able to dispose of that blood glucose. So what happens when you drink or when you eat a meal is that your blood sugar spikes, and you don't want that spike to stick around very long. If your body is healthy, it deals with that raised level of blood glucose very quickly, and it brings it back down very quickly. That's a healthy profile. That's what we call good glucose management. So how good is your body at disposing, essentially, of that glucose? And the way it disposes it is that cells in the body, including muscle cells, will suck up that glucose. And it's called your disposal index, or your disposition index, it turns out. So what she found, Ev Van Carter, with her studies, was that, firstly, the way that your body knows how to absorb glucose and suck in that glucose is that there is another chemical called insulin, which is released by the pancreas and beta cells of the pancreas. And that insulin will instruct the cells of the body to open up special glucose channels to absorb the glucose, and your blood sugar drops, which is good and healthy. Firstly, what she found was that when you are not getting sufficient sleep, the beta cells in your pancreas stop being sensitive to the signal of high glucose. So the beta cells, which normally are listening for this spike in glucose, and as soon as they sort of hear, no, they're not hearing it, they're sensing it, but as soon as they sense the spike in glucose, they release insulin. And that insulin will drop your blood glucose. But those cells had become insensitive to glucose, what we call sort of glucose insensitivity. And so the beta cells of the pancreas stopped releasing as much insulin. It didn't release enough insulin to drop blood glucose, so blood glucose remained high. If that wasn't bad enough, we've since gone on to demonstrate, and you can do this with really clever studies, taking tissue biopsies. The cells of the body, including muscle cells and fat cells, their receptors stopped being as sensitive to insulin. So firstly, you're releasing less insulin when you're sleep deprived.
Right.
But what little insulin you do release is not instructing those cells to open up the channels to take away the monsoon of the glucose that's flowing in the channels of the body. So on both sides of the glucose regulation, on the release of insulin to instruct cells to absorb glucose, and on those cells themselves to be sort of instructed by insulin, those cells became less sensitive to the insulin signal. And so as a consequence, your overall ability to deal with glucose became far more degraded, and blood glucose remained higher, which sets you on a profile of looking pre-diabetic.
Couple that with the standard American diet, and
and you're off to the races in terms of
and eating late at night. So actually, are you familiar with the studies? I know Dr. Sachin Panda actually is the one who told me about this. And melatonin is actually what is responsible for shutting down the pancreatic beta islet cells from producing insulin. So I wonder how much of the sleep deprivation, the melatonin system's involved in that.
Yeah, so in those studies, what was good is that they held constant circadian rhythms, they held constant ambient light, and they even held constant physical activity. The control group was sort of, they were in bed for 8 hours, but the people who were sleep deprived, limited to 4 or 5 hours, during the 8-hour window that the other people were actually sleeping, they had to lie recumbent in bed with no physical movement.
Man.
So you controlled, but it was a great study because you controlled for physical activity as well. So we now really understand the link between a lack of sleep and poor glucose management very, very well indeed. And we also know the stage of sleep that's important. It's, again, deep, slow wave sleep. The study that I described before, where you're playing those annoying tones just below the level of awakening, so I can remove your deep quality of sleep, you can do that same thing again, and you essentially produce that same diabetic-like consequence just by removing or excising deep slow wave sleep.
So you're doing that, and then on top of that, some of your work has shown that you're now also going to have a preference to eat the very food that raises your blood sugar levels, right?
Yep.
And so it's something I've definitely
high glycemic.
Yeah,
food. So this is a whole. So it all fits in, I think, to this energy balance. So, firstly, what we know is that your regulation of blood sugar, of blood glucose, is profoundly impaired by a lack of sleep. But what about your calorie intake? What about your obesogenic profile, setting aside your glycemic profile? So what we've discovered is that when you're not getting enough sleep, two appetite-regulating hormones go in opposite directions. These two hormones are called leptin and ghrelin. And I often, think of them as, they sound like hobbits to me, at least, leptin and ghrelin, that J.R. Tolkien would have written about them. But they're not, they're real hormones. Leptin is a hormone that signals satiety. What I mean by that is when you have high amounts of leptin, it tells your brain you're full, you're satisfied with your food, you don't want to eat anymore. Ghrelin is the other hunger hormone. When ghrelin is increased, you feel unsatisfied by your food, you feel hungry, and you want to eat more. So after you eat a meal, normally what happens is that levels of leptin increase, and levels of ghrelin, the hunger hormone, you can think of ghrelin as like a grumbling tummy, ghrelin goes down. And this means that you stop eating, you don't want to eat anymore, and you're full for a duration of time period. When you are sleep deprived, levels of leptin, which normally signal to your brain you're full and you're satisfied with food, that hormone is impaired by a lack of sleep. So you lose the fullness, satiety signal in your brain. If that wasn't bad enough, the hunger hormone, ghrelin, actually increases. So it's a double whammy effect here. Right. What does that lead to? It leads to a strong obesogenic profile of energy consumption, of food consumption. So what we, and Ev Van Carter, in fact, has done all of these pioneering studies, and we've done some of them now too. Typically, you tend to overeat during main meals. So you will typically eat somewhere between about 200 to 300 extra calories if we give you a meal and we measure all of the food on your plate and we ask how much did you eat at that one sitting. You tend to overeat by about 200 or 300 calories per main meal sitting.
Wow.
Now, you could say, well, actually,
that's after a full night of sleep.
Well, that's when you've been limited to maybe 4 hours of sleep for a week. Now, someone, and the reviewers of these papers, in the early days said, well, that's because when you're awake longer, being awake is more metabolically demanding, and you're probably moving around more. Not true. It turns out sleep, firstly, is a remarkably metabolically active state. You're very active when you're metabolically when you're asleep. In fact, the difference between being asleep versus being awake is only about, for a whole night of sleep, the difference of about 140 calories.
Wow.
Which is like a small cookie, essentially. So yes, when you're awake longer, you do burn more calories. But the amount of calories that you increase in your intake far exceeds anything that you expend by way of being awake a little bit longer. If that wasn't bad enough, though, it's not the main meal where the trouble lies with sleep. That's some of the problem. The other studies that are even more sort of devilish are where you give these sleep-deprived subjects the same meal, but then you give them a snack bar. And it's an ad lib food buffet, essentially. And you can eat as much as you want. And they allow you to eat in a room by yourself, so there's no social pressure. So you don't restrict your eating, or it's just true eating. And of course, we measure everything that you eat. And it's snacking that is the dead giveaway here. You end up eating 300 to 400 additional calories by way of snacks. This is after they've eaten a 2,000 calorie meal in one sitting. They will then go away and they will eat an additional 400 calories at the snack bar. Wow. So as a consequence, what you're doing is you're increasing the total caloric intake, which sets you on a path towards being overweight and obese. Then the discovery came that it's not just what you eat, it's not just how much you eat, but it's what you eat. And what Eve Van Carter discovered in her early studies was that if you give one of these sort of food buffets, and you can eat anything, it goes from, sugary treats to salty treats like pretzels or potato chips, to heavy-hitting stodgy carbohydrates, breads, pasta, pizza, all the way to salad. What you find is that you eat more of all of the food groups, but you eat mostly, in terms of an increase, the stodgy, heavy-hitting carbohydrates as well as the sugary foods. And if we know anything from the recent movement in food, particularly from people like Gary Taubes, who's written wonderfully about this type of stuff, that's the food that sets you on a path, again, down an obesogenic and also a poor glycemic control profile. If you look at all of the cardiometabolic markers of health, when you're eating excessive carbohydrate, heavy, rich, and particularly simplified sugars, they're bad for your health profile in general. It's exactly the foods that you eat when you're underslept.
Is there a feedback loop on those foods affecting your sleep?
There is.
There is.
So I would say this is probably, apart from maybe the gut microbiome, of which there is now some evidence, and we're starting to look at this too at the Sleep Center, it's probably the least well understood. But the bottom line is that if you're eating a diet that's high in carbohydrate, especially high in processed simple sugars, and low in fiber, you tend to have worse sleep. You take longer time to fall asleep. The amount of deep sleep that you get is less, and you have more fragmented awakenings throughout the night. Now, I don't think there's enough evidence right now for me to hang my hat on any dietary prescription for sleep. In 5 years' time, I think we'll have a very different conversation. I think absence of evidence is not evidence of absence. I think we'll get there, and I think food is going to be a big part of that equation. I think the gut microbiome too. I think that's what we've seen. When in a few of the studies where you limit people, you sleep deprive them, or you put them on a jet lag routine, you see the balance between the sort of Bacteroidetes sort of class of the microbiome versus the Firmicutes. That ratio goes in a balance that you don't want. So typically in sort of obese people or people with diabetes, you get a higher ratio of the Firmicutes relative to the Bacteroidetes. When you modulate sleep and you shortchange sleep or you put sleep on a jet lag profile, that's exactly the same gut microbiome sort of dysregulation profile that you see. Wow. So I think it's going to be a great, and I think part of
they're on their own circadian rhythm as well, the bacteria.
They are, and yeah.
So is that why? Because their ratio is changing?
I think it's possible that it could be a circadian rhythm. I think it's also possible that it could be down to what we described before, which is the fight or flight branch of the nervous system. That when you are underslept, it's like revving a car, but in neutral. It's desperately bad for the engine. That's what happens when you're sleep deprived. You get this ramping up of your fight or flight system, and it just stays there with chronic sleep deprivation for as long as you're chronically sleep deprived. And 1 out of every 2 adults in first world nations is chronically sleep deprived. I think it leads to a release of stress chemistry, particularly cortisol. Cortisol is known in the gut microbiome to produce this imbalance. What's the pathway? I think it's probably a bunch of nerve fibers from the brain into the body called the vagus nerve, and we're starting to do a lot of work on this now. I think the vagus nerve we know has a direct mainline pathway, or provides a mainline pathway from your brain to your gut, and that's why there is a very powerful brain-gut relationship. I think that's one of the mechanisms by which the gut is affected by sleep, which gets me excited because if that's true, flip the equation. Could the gut microbiome be a path through which we can reverse engineer a signal for better sleep in the brain? Yeah. I think that now becomes a parsimonious hypothesis, and it's one that I'd like to test as well.
There was a really interesting study looking at the effects of a particular strain. I think it was the Rhamnosus strain of they produce GABA in the gut.
Yes.
But GABA doesn't cross the blood-brain barrier as far as I think most evidence suggests it does not.
No.
But
so the brain has GABA, but it's not coming from the brain.
Right. Yep. But there was some studies that were sort of speculating that there's through the vagal nerve, because some of the afferent neurons in the gut were stimulating it, and they were more like relaxed or something. They were producing GABA in the brain through the vagal nerve, and GABA affects sleep, right? So there'd be some. It sounds like there could definitely be some sort of interesting.
And that's one of I think the things in anxiety that we see is that it's a failure of the brain to dampen down and basically invoke inhibition throughout the brain to quiet down these regions.
That particular strain of probiotics was shown to help with anxiety. Small trials, clinical trials in humans. Of course, the initial studies were preclinical in animals, but it has been shown to actually help improve anxiety.
It does?
Yeah.
My guess is that if that's true, if you were to look at sleep, I would be surprised not to see a sleep benefit by way of an anxiety reduction. In my lab, that's probably one of the most reliable things that we see when we deprive people of sleep of any dose.
That the anxiety goes up?
Anxiety goes up. And it's almost, we've done the dose response curve. We've looked, hour by hour by hour. And as soon as you get past probably about 14 or 15 hours of wakefulness, anxiety starts to increase. The further you go into that sleep deprivation period, the more anxious that you get. It's a very robust, reliable effect.
So what do you think? It sounds like if you were to give people like some of the main things, the main interventions they can do to help improve their sleep. A lot of people are interested in prevention. A lot of people listening and watching are really interested, including myself, in prevention. And it sounds like things that lower anxiety are obviously important.
Critical.
Yeah, for improving sleep.
Yeah. I think the prescription I would have, firstly, I think it's good to recognize those 4 pillars of sleep.
Yeah.
That, depth, duration, continuity, regularity. But I think there are 5 actionable things that people could do tonight to start getting better sleep. And we've mentioned many of them. The first is darkness. You really do need some degree of darkness at night to release that hormone melatonin, which helps trigger the timing and the healthy onset of sleep.
And you would say about maybe 4 hours before your bedtime, or what would you say?
Yeah, I would say 3 to 4 hours is the time to start thinking about your light saturation exposure, certainly in the last hour before bed. And there are ways that you can do that. You can install software on your computer if you really have to look at it. Mm-hmm. But I would advise against that because I think computers cause and trigger anxiety. I think, in fact, if anything, my estimation right now is that the blue light from those screens is detrimental. I think the evidence is favoring a blockade of melatonin and a reduction in REM sleep. They did this great study. They took people with an iPad, 1 hour of iPad reading versus 1 hour of book reading. iPad reading dropped or blunted melatonin by over 20%. The peak of melatonin didn't arrive until 3 hours later. This is 1 hour of iPad reading. They had less REM sleep, and they were
reading like.
They were reading just a book under dim light versus reading the same book on an iPad. When they woke up the next morning, the people who'd read the iPad felt more unrefreshed. They subjectively knew that they had not slept as well. What was interesting is that when they stopped the iPad reading, there was a washout effect, that there was a blast radius of reading the iPad, and it continued into subsequent nights, even though they'd stopped reading the iPad. So I think light is a feature, but I also think part of the problem with computers and iPads and iPhones, and I don't mean to sound like a prude about this, but they do trigger anxiety.
Yeah.
They are what I would describe as anxiogenic pieces of hardware. Yeah. Unless you are, and if you can do this, please write to me and tell me how you do this, but most people get a lot of their anxiety infusion in part through these devices. A recent study in teenagers actually demonstrated that part of the reason that they were having sleep disruption by using phones was not necessarily about the light, but was because of FOMO, fear of missing out. That if you weren't online, you would miss out on some key social communication. And they were suffering because of that too. But I digress. My first recommendation is watch the light saturation, watch the light pollution. And you can think about it like that in the evening. So an hour before bed, certainly, close computers down, try not to stare at phones, and dim half the lights down in the house. It really is powerful. The second is temperature. Try to set your bedroom temperature to somewhere between about 63 to 66 degrees for most people is optimal. Colder than most people think.
Yeah, that is definitely colder than.
Yeah, and if you get cold feet, it's okay to wear socks, but cold it must be. The third thing is what I would suggest is walk it out, which is don't stay in bed awake. This is one of the mistakes that a lot of people make. In this era, I think most people, because of anxiety, were wired and tired. And one of the problems when you are lying in bed awake for a period of time, anything more than 20 minutes is not great. Because what happens is that your brain very quickly starts to learn the association between being in bed is about being awake rather than your bed being the place of sleep. And so it learns this association. And so many of the patients that I'll speak to, they'll say, look, I'm falling asleep on the couch watching television, and then I get into bed and I'm wide awake and I don't know why. And the answer is because you've made the association between your bed is the place of wakefulness, not your place of sleep. So the answer is you need to break that association. Get out of bed, go to another room, in dim light, just read a book, no computers, and only return to bed when you feel very sleepy. And the first night, this may mean that you're awake for 2 or 3 hours. And it sounds bad and it sounds strange coming from someone like me, but that's better than staying in bed awake for those 2 or 3 hours. And over time, gradually, by only returning bed when you're sleepy, your brain will relearn the association that it once had when you were a child, and you can relearn it, which is that your bed is a place of deep sleep and sound sleep. So that's the next thing. I think the final two things we've touched upon a little bit, which is alcohol and caffeine. Caffeine, many people know, keeps them awake. It's a stimulant. It's what we call a psychoactive stimulant. It's the only psychoactive stimulant, by the way, that we readily give to our children in an unregularized, free way, which I think is a problem. Caffeine has several problems with it. Firstly, because of it being a stimulant, it can keep you awake, and it makes it harder for you to fall asleep. A lot of people, though, will say to me, look, I'm one of those people who can have a cup of coffee with dinner and I fall asleep and I stay asleep and I'm just fine. Even if that's true, we and others have done these studies. If you give someone a standard dose of 1 cup of coffee in the evening, 200 milligrams of caffeine, the amount of deep sleep that they have is reduced by 20%. You would normally have to age an individual by 10 or 15 years to drop your deep sleep quality by 20%. Or you can do it simply by having a cup of caffeinated drink or coffee in the evening. So caffeine is a problem. The other problem with caffeine is its duration of action. Caffeine has a half-life of about 6 or 7 hours, and a half-life simply means the amount of time it takes for 50% of the drug to still be in your system or 50% of it to be cleared. Caffeine has a quarter life of about 12 hours. In other words, if you have a cup of coffee at noon, quarter of that caffeine is still circulating in your brain at midnight. So if you have a cup of coffee at noon, it's the equivalent of getting into bed at midnight, and just before you turn out the lights, you swig a quarter of a cup of Starbucks and you hope for a good night of sleep. It's probably not going to happen. So the advice would be try to cut caffeine off around about midday if you can. And even if you're someone who can fall asleep fine, stay asleep, you should just know that caffeine can still impact your sleep. It's what usually creates the vicious cycle, by the way, that those people will wake up the next day, they feel unrefreshed and unrestored by their sleep. They don't remember waking up, so they don't think it's the cup of coffee. But now they start reaching for 2 cups of coffee in the morning rather than 1. They've got now more caffeine in the system. The next night they have even less deep sleep. The next morning they wake up even less refreshed. And now they drink more caffeine, self-fulfilling prophecy. Right. Final one is alcohol. Alcohol is probably the most misunderstood sleep aid or sleep drug. It's what most people usually reach for when over-the-counter medications have failed. Alcohol is a sedative. It's a class of drugs that we call as sedatives, and sedation is not sleep. So when you drink alcohol, what you're doing is sedating your cortex. You're just knocking yourself out, and that's why you think that you fall asleep faster. There are 2 other problems with alcohol. Firstly, alcohol will litter your sleep with many more awakenings throughout the night. And in fact, some people can even see this on their sleep trackers, even though they're not necessarily as accurate as my sleep laboratory would be. Even with that less accurate measure, you can still see the impact of alcohol in sleep. So it litters your sleep with awakenings, fragmenting your sleep. So this comes back to the third of the 4 pillars of good sleep, which is continuity. It takes away your continuous sleep and it makes it fragmented. The final part of alcohol is that it's one of the best chemicals that we know for suppressing REM sleep, alongside marijuana. Now, by the way, I should say that's THC specific. If you look at CBD, the evidence seems to be less clear. CBD actually doesn't seem to be as detrimental to your sleep as THC. If anything...
Yeah, because there a lot of people, I mean, again, this is just anecdotal talk about how marijuana improves their sleep.
Yes, yeah. So marijuana, and again, we have to separate sort of the active from the inactive component. THC, tetrahydrocannabinol, is the active component, and CBD is the sort of the non-hallucinogenic component.
But they're both in if people are taking the whole plant.
Typically, exactly. Now, with strains and drops that you can buy, you can separate those out. You can play around with the ratios, and you can get very low THC to very high CBD. THC does tend to decrease the time it takes you to fall asleep, but it tends to make you sometimes wake up more throughout the night, but it certainly does seem to block REM sleep. One of the other problems with THC dosing of sleep is that you become dependent on that for sleep. And when you stop using THC for sleep, you have quite bad rebound insomnia, which leads to then a perpetuating cycle of dependency. And I think, I'm never keen for dependency on anything, be it dependency on, any, food substance or anything. I think you should, be able to generate all of the physiological pathways and processes that you need, naturally without dependency. CBD is interesting, though. There is nowhere near enough data for someone like me to make any recommendations. So all I can do is tell you the very limited data that there is right now. CBD does not seem to produce the degree of REM sleep impairment that we've seen with THC. What's interesting is that low dose CBD actually seems to be wake promoting. So you actually are sort of forcing yourself more awake. High dose CBD seems to help people sleep more consistently. I would have thought it would be the opposite, that low dose would have been better than high dose, but the opposite seems to be true. Now, we don't know about the dependency, we don't know about the long-term effects, so I am not going to sit here and give any recommendations regarding THC use or CBD use. If you're using any compound, be it alcohol, be it a sleeping pill, which sleeping pills, by the way, come with deathly consequences and higher risk of cancer, or you're using, markedly increased risk.
Is that because there's something directly the sleeping pills are doing, or because the way it affects what does it do to your sleep, sleeping pills? A lot of people take Ambien.
So in the past month, 10 million Americans have swallowed some kind of sleeping aid, either prescription or over-the-counter, monumental amounts. I often joke that I think, and it's not really a joking topic, but it took George Lucas about 40 years to amass $4 billion in profit from the Star Wars franchise. It took Ambien less than 20 months to amass $4 billion in profit. That tells me everything about the insufficiency of sleep and the desperate need for sleep in this modern 21st century era. But the problem is, Ambien isn't part of that same class of drugs that alcohol is. It's what we call a sedative hypnotic. It works on the same receptor, which is the GABA receptor. Now, it tickles the GABA receptor in a different way to that which alcohol does. But what we found is that sleeping pills, and I won't name any names, but including the one that you described, they are sedating the brain. You're not going into naturalistic sleep. If I look at the electrical signature of your sleep when you're on a sleeping pill versus natural sleep, it's not the same. Secondly, what we found is that those sleeping pills can often come with a grogginess in the morning and some forgetfulness. Third, what we've found is that in animal models, and this is work that was done by Marcus Frank, who's a wonderful friend and colleague, he was looking at how the brain rewires itself during sleep, and the brain does, particularly during the development. And he has a model in animals where if you sort of put a patch on one of the eyes when the visual cortex is developing, the visual cortex shifts over to developing more wiring to the eye that remains open. And it's called the monocular deprivation paradigm of brain plasticity, and it's a very well worked out model of brain plasticity. If you give those animals some exposure, once you've patched the eye to the eye that remains, you drive learning and plasticity, and then you allow it to sleep, sleep will strengthen the synaptic connections that have been made during the day by about 100%.
Wow.
So sleep is almost as powerful as experience during the day. That's how sort of strong and powerful it is. But what he then did was a study where he dosed those animals with Ambien. Now, it turns out that those animals slept even longer, if you look at the data, than the animals who weren't dosed on Ambien. And the prediction would be, surely they would have as much, if not more, of that wonderful brain plasticity. The opposite was true. Ambien-induced sleep resulted in a 50% unwiring of the connections that have been made during the day, rather than potentiating them. And that frightens me, because if you look at the prescription age of sleeping medications over the past decade, it's coming down and down. I don't know how long it's going to be before prescription medication comes into a pediatric realm, and if those data hold up, it makes me worried. So I'm coming off topic a little bit, but we know that sleeping pills are associated with a markedly higher risk of death, as well as cancer, as well as your susceptibility to infection, particularly pneumonia. But returning to alcohol, it is definitely one of the most, I think, misunderstood drugs. But what I was saying regarding THC, alcohol, sleeping pills, if you are using anything to help you sleep, I think you have to ask yourself, are you just really treating, an open wound and not really actually trying to stitch it up? Because what that is simply doing is masking a problem that you're not dealing with. Why is it that, and this is not a criticism, I'm sorry if my voice sounds like that, and it's not. I'm so sympathetic to people who have sleep problems. We see them all of the time here. But you have to ask why. Why is it that you're struggling with sleep? Is it because you're of a certain chronotype and you don't understand your chronotype, and you're sleeping at the wrong phase of the 24-hour period and it's masquerading as insomnia? Or do you have too much anxiety in your life and you're blunting that anxiety with things like alcohol or THC or sleeping pills? You're just kicking the can down the road. You're just hitting the mute button, but the movie is still playing of damage. Whatever is causing that sleep disruption, is still there. You're just sedating your brain and trying to mask it. So I think people who are using those things, if they're having sleep difficulties, you should ask yourself, could I examine my life and really think more about what it is that is preventing me from sleeping? What's good is that you don't have to turn to any of those, because there is a non-pharmacological treatment that is just as effective as sleeping pills in the short term. It is completely safe, and it is more efficacious in the long term. And it's called cognitive behavioral therapy for insomnia, or CBTI. Based on its efficacious nature, and they've done lots of randomized clinical control trials, it is just as powerful as sleeping pills in the short term. But when you start working with your therapist, and you work with a therapist for several sessions across several weeks, when you stop working with that therapist, you don't go back to the bad sleep that you have. You continue on with your good sleep. Unlike sleeping pills, which is when you stop them, you have what we call rebound insomnia, which is that you tend to go back to the bad sleep that you were having, if not worse sleep that you were having before you started taking sleeping pills. And the dangers around sleeping pills and their lack of true benefit above and beyond placebo, which is, if you look at these meta-analyses, in 2015 or 16, the American College of Physicians made a landmark recommendation. They said that sleeping pills must no longer be the first-line recommended treatment for insomnia. It must be cognitive behavioral therapy for insomnia, because of both the deleterious, deathly, and carcinogenic consequences or association with, I shouldn't say cause, because we don't yet know cause, but certainly they are associated with higher mortality risk and higher cancer rates. CBTI, this cognitive behavioral therapy, must be the first-line recommendation treatment. The problem is most doctors don't know about it because most doctors get a less than 2 hours of sleep education during the medical curriculum. And this is another crusade that I'm on. I am desperately trying to reach out to all medical curriculum, not just here in the United States, but in all nations where you have medical programs. We need a greater degree of medical education. Our doctors are not at fault, not understanding sleep. They have not been educated about sleep. So I teach a class here at the University of California, Berkeley. It's usually around 500 or 600 kids. It's the science of sleep. And they get 25, hopefully meaningful lectures about sleep across the semester. They will have had somewhere between 10 to 15 times more sleep education than the standard doctor that you will go and see. Most doctors don't ask how much sleep that you're getting, despite it being this fundamental, sleep is a life support system, and it is Mother Nature's best effort yet at immortality. And it's a key to disease, and it's a key to potentially helping treat or even prevent disease. Most doctors don't ask because most doctors aren't educated.
Right. Nutrition's another one of those areas.
It's right up there, yeah.
But thankfully we have people like you who are doing phenomenal research and also communicating that research quite nicely. I read your book. It was a really great book, Why We Sleep. So if people do want to learn more about your research, about sleep, about anything related to sleep or what you do, they can find you.
They can find me, unfortunately, all over the internet. My handle on social media is Sleep Diplomat, all one word. So at Sleep Diplomat, you will find me on Twitter. You will find me at sleepdiplomat.com on the web. My center here at University of California, Berkeley is the Center of Human Sleep Science. If you just Google that, you will find that. And there's lots of content. And if you would like an education on sleep, or you're just interested in sleep, or you're struggling with sleep, the book, which has been out now and is out now in paperback, is called Why We Sleep. It is published by Scribner here in the United States, and it's published by Penguin back in the United Kingdom.
Well, Matt, thank you so much for taking some time out of your busy day to speak with me. I really, really enjoyed this conversation.
You're very welcome. Thank you so much for being such a wonderful sleep ambassador. I am on a mission. I'm desperately trying to reach the public because I think this message has been the neglected stepsister in the health conversation of today. But I can't do it alone. I need to partner with fantastic scientists and public figures, people like yourself who provide this platform and this forum. So I'm going to anoint you as a sleep ambassador now as well. So thank you, but just genuinely thank you for this opportunity to reach your audience and speak about sleep. I really do appreciate it so much. So thank you.
Awesome, thanks.